So can we start the session?
Yes, ma'am.
Can we start it? Okay. Good morning, everyone. I am Pratibha Singh. Today, I am the coordinator of this session, Fibrous Composite. I would like to welcome the chair of this session, Professor R. Chattopadhyay. He is professor at IIT Delhi. Now, I would like Professor R. Chattopadhyay to hand over the session. Sir, can we start?
Yeah, sure. Good morning to all of you. So we are going to start the very first session and for this international conference on textiles for advanced technologies. So we have quite a few speakers in this session. And there are 5 speakers. And the time that has been allotted for each speaker is around 25 minutes. So therefore, I will request the speakers to stick to the time so that we can finish in time also. And with this, I would first request our first speaker, Professor Alagurusamy. Professor Alagurusamy is well known in India and abroad also. He has been working in the area of composites, textile composites for a long time. Presently, he is the head of the Department of Textile and Fiber Engineering, IIT Delhi. He recently has received an award of eminence and contribution to the professions of textile engineering by the Institute of Engineers. With this, I would request Professor Alagurusamy to present his talk, which is on thermoplastic composites, processing difficulties, and remedies. Over to Professor Alagurusamy.
Thank you, Professor Ravi Chattopadhyay. Can everybody hear me?
Yes, I can hear you.
You can see the slide?
The slide is also visible.
Okay. So, good morning to all. It's a nice conference which is going on. So, it's my pleasure to present this presentation on the thermoplastic composites, processing difficulties and remedies. Now, the composites technology has been established based on the thermosetting matrices. This all of us may be aware. In the defense, it started with the defense industry, aerospace industry. So there, thermosetting matrices like epoxy and other thermosetting resins were the ones used initially, even now also. The technology started with them. But when it moved to commercial end users like automotive industry, sporting goods industry, all other industries like civil construction, now there recyclability becomes very important, and also other important properties like the damage tolerance and other things are becoming important. The thermosets are quite brittle, and they, in order to manufacture them, the pure cycles are lengthy. At the end of the product life, it cannot be repaired or it cannot be recycled. So disposable is a main problem, particularly in the case of automotive industry. The original equipment manufacturers, they are responsible for disposing also. So in that case, thermosets pose a huge problem. So slowly, thermoplastics are emerging as a strong competitors for this because of these difficulties associated with the thermosets. So thermoplastic matrix composites, they are distinguished by their ability to be reshaped. The part it can be fiber reinforced component, but it can be heated and reshaped to some other product as well, right? So then also, since thermoplastics have high strain to failure, so the toughness and fatigue endurance properties are also very good compared to thermosets. And also thermoplastics, they require shorter and simple processing cycles, which is not that much messy as the thermosets, because in case of thermosets, one has to handle with the liquid resins, and a lot of care has to be taken so that it doesn't, cross-link inside the machine itself, right? That can be a big problem. So due to this, thermoplastic composites are, growing fast, and the manufacturing different technologies are being uh, developed with this. But it does come with some challenges, mainly because of the high melt viscosity associated with the thermoplastics. So because of that, resin penetration inside the fiber bundle becomes a problem. That in turn leads to increase in the voids in the composites. In order to overcome this void content and then resin penetration, if one goes for higher processing conditions like higher pressure, higher temperature, and all that, then again that also comes with problems of their own. For example, if you go for higher temperature, actually, then the thermoplastics may degrade. The problems, associated with the degrading of the matrix is not good. It will affect the composite properties. And if one starts applying higher pressure, then again, the alignment of the reinforcing fibers during the consultation becomes an issue. So because of all these, some challenges are there, but some remedies are proposed. And what I will do in this case, there are several ways of tackling it by using flexible toe press and take advantage of textile preforms also. So because of the shortage in time, I will just only go through the methodologies and some salient features. I will not go through the results, discussions, and all those things. Obviously, all these techniques yielded better results. And at the end of the lecture, I will give a reference to a book which is published just recently, 2 months ago, which gives consolidated, a consolidated view of all this work which I'm going to be presenting. So the solution could be using flexible toe packs, which can be also used for textile preforming. All of us are aware that textile preforming has a lot of other advantages associated with it also. So because of that, whatever toe pack, which is also called as hybrid yarns, it needs to be flexible. So in the toe pack, as all of you are aware that the resin is already placed within the high performance fiber bundle, so that it becomes easier for the resin to melt and then redistribute. This particular slide, this will explain what I am telling in a simple manner. So if you have the reinforcing fibers and the polymeric reinforcement, either in the form of sheets or powder, if it is placed separately, then obviously this polymer has to melt and travel more distance to reach the core of this fiber bundle. Okay, so due to that, there will be issues as, like your very high pressure, high temperature, and all those things. Whereas if the fibers, high performance fibers, let us say block fibers, are distributed very well with the matrix forming material. This can be in the form of fiber or powder also. In that case, these yellow ones, which are representing the matrix, they have to simply melt and redistribute. So melt flow distance to cover all these voids will be very less. Well, the starting point for my work was this particular US patent, which myself and Robert Davis obtained when I was working with custom composites materials in USA. So from this you can very clearly see the powder particles, and these are the carbon fibers. Most of the particles before melting, they were almost comparable to the size of the carbon fiber itself. So after partially fusing, after powder coating and then partially fusing, you can see it will still retain its flexibility. So it was very easy to weave this material also. Okay, so this is one of the approach. There are other approaches like the commingled yarns, where the reinforcing fiber matrix forming material in the form of filaments, then core spun yarns, reinforcing fibers in the core and matrix forming material on the sheath. and co-wrapped yarns, stretch broken yarns. These are all available techniques, right? So these techniques, if they are suitably used, then one can overcome this problem of melt viscosity effectively. Let me first talk about the work done by our group in the area of commingled hybrid yarns. It's a very simple technique. The heart of the process is the air jet nozzle. Okay. Then your matrix forming material in the form of filaments and also reinforcing fibers, filaments, they can be fed through this nozzle, and because of the commingling, both of them get mixed. In the mingling process, you get nip and open structure like this. The nips gives the stability, even during weaving because of repeated cyclic loading and all that. It doesn't come off. The typical mingling jet has air inflow from just single passage, which is perpendicular to the yarn passage. First, we tried that. We did the CFD analysis and all that of the flow diagram, airflow within this nozzle. This doesn't work properly because there was no mixing found. Then, then another configuration which was tried out, configuration 2. Okay, this is configuration 2, where multiple horizontal holes perpendicular to the yarn path. This also resulted in no mixing. Then, we went through the CFD process completely. Wherever there is, some nozzle geometry where it results in some turbulence near the air entry and then kind of laminar flow towards the exits, that results in better mixing. Okay. Otherwise, there is a grouping observed. If there is a even turbulence, turbulent flow extending up to the tips of the nozzles. That's not preferable. But something like this, it worked out good. It gives good mixing of constituent fibers. And this shows the airflow profile for the first one. And different types of nips were analyzed. You can clearly see, this looks like bright, so braided nips. This is entangled nips. Thorough study was conducted. A PhD work was done by Vinayak Outle. Some wrapped nips like that. And another interesting that we found was that when the well mixed section is there of the in this case glass fiber polypropylene, then the fibers on putting knot do not break that easy. Whereas wherever there is just this knot strength alone can provide the idea about the mixing. A very simple method. These are all some, the cross sections which are made and compared with the common method of flexible film stacking. So compared to film stacking, these composites produced with your commingling, it gives much better results, less voids and all that. And also, if you look at the microstructure also, the composites produced with the commingling, that gives very good bonding with the fibers. You can see, whereas film stacking, you can very clearly see a lot of dry fibers. Fracture mechanics also was analyzed, right? In all of them, they clearly indicate that your commingling results in a better composite. But of course, in many cases, resin areas were also observed in case of the commingling composites, just like in the side-by-side and film stacking also. So another method which we are working is on the electrostatic powder coated flexible toe plates. So here, complex shapes cannot be formed with the hot melt, because solution impregnation, film stacking, they result in stiffer prepregs. The commingling we have seen, it results in some resin-rich areas also, wherever mingling is not good. So the powder coating method, it's a very simple method which avoids binders and solvents and of this kind, and it gives also very good results. This is a setup which is the fabricated. I will show the photograph in the next slide also. So the heart of the process is this fluidized bed. The powder in micron sizes, they are fluidized, by passing fluidizing air here. So the fluidized, when it is properly fluidized, then it looks like almost boiling water. The powder is thoroughly mixed, and they are not in clumps. So this is passed through the spray nozzle, electrostatic spray nozzle, and a cloud is created in this, and which actually deposits the powder on the toes, right? And then it goes through a heating chamber where it's partially melt, and then it is taken up on a winding device. So this shows the most important aspect of this process, that is fluidizing bed. After fluidizing, the material is sucked by the venturi pump to the spray gun, and it sprays the spray gun, the powder inside the chamber, powder chamber. In that process, the powder is also getting electrostatically charged, because of the corona charging. Okay, so the electrostatic spray gun, it charges the powder. So you get a charged cloud inside this chamber. You can see this picture also, right? So this gives, this is the feeding setup. This can also have a spreading setup. If you can spread the carbon fiber or any high performance fibers, then again, the fiber matrix distribution will be much better. So the spray gun, and then this is the heating chamber, and the material is wound on this here. So again, you can see the cross section of this. So this is the carbon toe. In this case, it's flattened a little bit, so that you are able to get better mixing of fiber and the matrix right before consolidation itself. And also the temperature inside the hot oven, it plays very important role. And this temperature is going to be decided by the fiber volume fraction, how much powder we put on it, what is the line speed, and all those things. Another method which we use is to use the dress spinning system, through which we can put the core yarn right at the center. This core yarn can be carbon or glass or any high performance fibers. So that will go in the core, and the matrix forming material will be fed from the carding drum, right? So since the core is hardly twisted in the friction spun or dress spun yarns, the strength utilization is going to be also very good. You can see, compare this is a core spun yarn, dress spun hybrid yarn. The core is again carbon, and this is polypropylene. Here, the powder coated material you can see here, and it has the powder after partial fusing, right? It even penetrates to some extent inside the bundle also. Okay, so definitely the powder coated material will demonstrate higher the fiber matrix distribution before the consolidation itself. So that is again confirmed with the SEM microscopes and all that. This is the draft and powder coated. This is film stacking. The powder coated products compared to draft and film stacking, it was giving much better results. Even the micro CT also clearly shows that in case of powder coating, there is more fiber breakages. It takes higher load, and then it fails. Then obviously the quality of composite is much better, because it does not delaminate like the film stacking, and then the fibers do not participate in the failure that easily. And the dress spun composite, it lies somewhere between the powder coated and the film stacked composites. And again, microcity at different layer levels, you can clearly see this one is the draft and this is powder coating. So inside the composite also, you can see a lot of voids in case of the draft spun, whereas with the powder coating, the amount of voids are very, very less. Okay, then we extended this principle of the flexible toe preg to the natural fiber based hybrid yarns also. And we tried out the twistless flexible hybrid yarns. Now, you see, all of us are textile technologies. We know very well the moment you introduce twist into the structure, the axial strength contribution of the fibers is going to be reduced by a factor of cos square theta, where theta is the angle of inclination. So if we can produce, the stoperex without twist, then axial strength translation is going to be much better. The composite will give much better axial properties, right? So that was the aim of this particular work also. So in this case, again, we compared with the draft spinning. I'm not going through that, what is done. But the draft spun yarn, mainly when you go for weaving, there is a problem, the seep seepage problem is there. So in order to avoid that, some thermal heat treatment is done. So before treatment, draft spun yarn looks like this with all the hairs and all that. After that, it is partially treated so that the flexibility is not lost completely. So this is one type of structure where the core is not twisted. Zero twist is in the core, right? In the dress spinning, the core is not provided with any twist, real twist, right? So on consolidation of this dress spun hybrid yarn also, one can get fibers with high alignment in the composite. You can clearly see, these are the cross sections which are obtained. The flax fiber is used for reinforcement. Flax is, inside the core, at the core, and the PP is at the sheath. We tried out different temperatures and all that. So details are discussed in the published literature. The another method that was used for making zero twist hybrid yarn is to use the gill box drawing. So the material is drawn, right? The flax sliver is drawn using this, and then it is condensed. There is a light heater was introduced in the condenser, right? So that as the material is passing through the matrix forming material polypropylene is partially fused. Okay, so that is a heat treatment, thermal treatment unit. So you can see this is the condenser, and condenser is provided with the heating elements. Okay, so because of that, you can see that there is a partial melting of the polypropylene on the sheath, right? Most of it is on the sheath. The core remains, it's not molten, right? So it still retains its flexibility. So this was even woven also. So the process conditions like line speed, temperature, and the fiber volume fraction, all of them has to be optimized. And it was optimized to get the maximum flexibility. Okay. So, for example, the distribution of fiber and matrix, that is flax and PP, again it was tried out of with different passages of drawing, higher and higher packages to get better mixing, right? And where the PP and flax is very well mixed, right? So that you will get a composite where fiber matrix distribution is good, which will result in higher properties. This is the product that came out of this, right? It shows quite flexibility, so that it could be woven also, right? You can see, as it goes through the number of passages, it gets thinner also, and fiber gets more aligned without any twist. We could make the toe pegs, and so two patterns are already applied on this. One is on the process, the other is on the product. So then composite properties were characterized also, tensile fracture, bending, and then the SEM analysis also has been done to see how the fiber matrix distribution, and then the pulling out of the fiber, how the strength develops. All those things have been analyzed and published. So all this work which I have gone through, and some more also. For example, we are also working on the dispersion coating, coated toe pegs. So all of them are compiled together, and a book is published, The Flexible Toe Pegs and the Thermoplastic Composites. It was edited by me, and it was just published only 3-4 months ago by CRC Press. So if you are interested in the results of this book, then results of this work which I have presented, you can really check on this book. Okay, so that's it. I thank you all for your patient listening. If you have any questions, it will be a pleasure for me to answer.
Sir, Professor Ariguru Swami.
Yeah.
Sir, thank you very much for a very nice and engrossing presentation. I'm Shailesh Kaushik. I met you about my innovation also.
Okay.
My question is that have you used these in civil structures for their torsional shear or bending strength? And what have been the results?
No, actually, we mostly concentrate on the co-product development, and then what is the effect on the composite laminate properties. We have not taken it up to the end use level.
But
all our co-products, they result in much better mechanical properties compared to the normal film stacking method or other methods.
So that includes better torsional shear or bending strength.
Definitely, it will give much better properties.
And better.
We have not gone into the final end use level.
And better elasticity also.
Better elasticity also, because the fibers are more aligned. So it will be doing very good in the applications where axial loads are coming in.
So the Young's modulus will be more or less in the region of composites.
Yes. It will be very good. See, particularly when you are going for civil and other automobile applications, particularly in automobile applications, the impact properties are very important, right? So the laminates were tested in impact also. They are giving very good properties. So this material can be taken further. Maybe somebody else.
Sir, one last question. Hemp has been used in composites and even in making small aircrafts. So have you tried hemp also?
Hemp, yeah. Actually, this natural fiber, flax fiber material, which we have developed, the end use which was kept in mind was automotive composites. And Mahadev was the PhD student who worked on it. He is in France. And actually, they are trying this out to make some automotive components. Obviously, the strength is not going to be as high as the carbon fiber composites, which are used in. These are not going to be used in load-bearing applications in any automobiles or aircrafts. This will be suitable for non-loading, load-bearing applications. In fact, one small section work was carried out to compare the glass fiber polypropylene composite, right, and the flax fiber that we have developed products. So then we made a comparison. So almost the flax composite was coming up to 80% of the glass composite performance.
But say,
but again, I won't recommend this one for the load-bearing applications.
But for application like wind turbine blades, where there is not much of load bearing,
wind turbine blades, they come under very heavy shear forces and all that. Okay, as they rotate, very high levels of stresses will be coming. So in that, I don't think it is recommendable to use, try to use this material.
Okay, thank you, Professor Alagrusami. Now, because we have many more speakers, time is also already too late here now. So thank you for your presentations.
Thank you, Professor.
And if any more questions are there, they can write to Professor Alagrusami or discuss in person. So I will now invite our next speaker. Next speaker is Professor Mukesh Kumar Singh. Professor Mukesh Kumar Singh is the professor and he is the dean also in Uttar Pradesh Textile Technology Institute, Kanpur. It's a very old institute. And his area of interest is fabric engineering and photovoltaic textile, technical textile, fiber science. And I know Mr. Professor Singh very well, personally also. So I will request Professor Singh to stick to the time of around 20 minutes, 15 to 20 minutes, so that we can take more questions and discuss.
Okay, sir.
Okay?
Thanks a lot, sir. Am I audible, sir?
Yeah, you are audible.
Okay. So, with all my due regards to Professor R. Chattopadhyay, sir, and Professor Aligar Swami, and all other dignitaries who are present here in this session too. I will talk about statistical optimization of bacterial cellulose from Acetobacter gynus, NCIM 2526 in low cost medium by using response surface methodology. If you will see the introductory part of bacterial cellulose, basically the synthesis of bacterial cellulose takes place at the interface of air and water in a media where we place the oxygen and sugar source as a nutrient. If we will synthesize the bacterial cellulose in static condition, we will get the membrane, which I have shown you here. And in dynamic condition, the pellicles are formed, and these pellicles are easily washed and dry, and we can use by mixing in an appropriate solvent for various purposes. If you will find in nature, cotton seed fiber consists 90 to 95% cellulose, bast consists 60% cellulose, regenerated cellulose fiber, they consist 50 to 60% cellulose. But the beauty of bacterial cellulose is that it consists 100% cellulose, which is not present in any other source in nature also. These are the microorganisms which are mainly responsible for the biosynthesis of bacterial cellulose. The agrobacterium, Shirshina, glucorinobacter, Azotobacter, Rhizobium, Aerobacter, Acetobacter, Salmonella, and Escherichia. These are the very, you can say, the beautiful attributes of bacterial cellulose, which makes this material very smart material, very useful material. It is a transparent material. It has very high water holding capacity. If you will talk about purity, it is 100% pure. Biocompatibility is also very good. Cell adhesion and proliferation of various human cells is also a very good capacity in this V-sheet. Biodegradability, high crystallinity, 70 to 80% crystallinity can be achieved easily without making any extra effort. Exceptional mechanical strength, hydrophilicity, high degree of polymerization, high nanoporosity, permeability to liquid and gases, that is also present here, flexibility and moldability. So all these attributes make this biomaterial very useful biomaterial nowadays. The application of bacterial cellulose on textile and other materials is possible if we will use this material in the form of functional finishes or carrier for a functional finish. It can be used in the form of a polymer to carry different other ingredients. This can be immobilized on various surfaces in the form of nanomaterial. It can be used in the form of bacterial nanocellulose, hydrogels. By using cyclodextrin as a carrier or as a coupling agent, the potential of bacterial cellulose enhances in multifold, and it can be used in the form of mild cells also. In the form of biomedical, it can be used for meniscus implant, artificial bone, artificial cornea, artificial heart valve, bound dressing material, and so others. You will see the active ingredients in the form of small molecules can be used as antibiotics, antiseptics, cyclostatics. In macromolecule form for antifoulistic, natural extract, enzyme, and proteins. If you will see the features of bacterial cellulose, which makes this material very smart, it is available in the form of glycan chain, which are joined by intra and inter-hydrogen bonding. Three-dimensional nanoporous gel structure is easily formed, or you can say the automatically formed on the joining part of air and water. Degree of polymerization that remains higher than 8,000. It can hold 90% water, and crystallinity may be achieved up to 80%. Bacterial cellulose alone or with drugs, or with a plant extract, or with other active substances that can be used for medical purposes successfully. You will see the how the bacteria synthesize this bacterial cellulose. The fructose basically be provided in the form of nutrient. Then it convert into the fructose 1-phosphate, and then by cleavage process it converts into the fructose 6-phosphate, then glucose 6-phosphate, and then UTP, glucose 1-phosphate, and then UDP, uridine diphosphate glucose. And these are the microchannels which basically extrude the cellulose in the form of fibrils. And when these fibrils are assembled and the glucose unit are aligned in beta form, then it form cellulobiose unit, and it comes in the form of a fibrillar structure. So this is the mechanism of bacterial cellulose synthesis with the help of different bacteria. If you will see the structural advantage of BC over other bacterial cellulose which are available in nature, it is a completely environment-friendly material. No need to treat toxic substances. Three-dimensional nanostructure is available. What is the research gap here? Basically, the other researchers also synthesize the bacterial cellulose. I'm not claiming that I am the only one person who synthesizes bacterial cellulose. Bacterial cellulose is synthesizing last 20 years, 30 years, but the yield is very low. Means 6 to 7 grams per liter is possible. Then high cost of production. Due to this very low yield, the cost of production of bacterial cellulose is quite high. Here we opt another approach that is very unique. We use different waste material, agricultural waste material as a nutrient, as a source of carbon and nitrogen in place of standard HS media. The process optimization was not tried by a number of researchers, and systematic design of experiment did not opted by these researchers. For the synthesis of bacterial cellulose or the optimization of process parameter for bacterial cellulose synthesis. So here we opted the bacterial cellulose production has explored more in static cultivation in culture media in comparison of the dynamic or kinetic condition. Many of these works have not focused on developing new culture media to overcome the effect of pH during cultivation. And there is a substantial need to optimize the bacterial cellulose production for low-cost production options. In the limelight of these research gap, the objective of this study was aimed to optimize the bacterial cellulose production from Acetobacter gallinatus NCIM to using beehive-based and Zaggeri-based as a cheap carbon source, as well as standard HS media to make the comparative study with HS media. So Vox-Beckon design of experiment has been opted here to optimize the pH, incubation temperature, and shaking RPM, along with the pitch. So these are the results, and these are our results of the comparative study of yield, which other researcher get, and we have achieved during this research work. So it can start from 2 grams per liter and it reach up to 4, 5, 6, and maximum up to 8. But here we started from 7, and now we have reached up to 12 grams per liter of bacterial cellulose yield during the incubation of 64 to 67 hours. This is the production protocol for bacterial cellulose synthesis. There are following steps in the bacterial cellulose synthesis: extraction of carbon source from beehive and Zaggeri waste by boiling it at 100 degrees centigrade, and then nitrogen source were added as per the standard protocol. Then preparation of modified media was completed, then sterilized, then we inoculate the Acetobacter xylem bacteria, then allow for incubation for 64 to 67 hours, and then bacterial cellulose was removed from that particular culture media. These are all 3 comparative protocols which we have opted for: HS media, beehive based, and for Zaggeri based. So almost the process are same. So you can see here in case of beehive based is the simple waste from this bee. Then beehive waste used as a carbon source, we boiled it and we segregated the as nitrogen source, and then mixed in media, and then we used as a media as a carbon source and as a nitrogen source. In similar protocol was opted for Zaggeri based also, and then the comparative study were made here. So these were 3 process parameters which we have opted: incubation temperature, RPM, shaking RPM, and nitrogen pH of nitrogen source. 25, 30, 35, 100, 125, 150, the shaking RPM, and 5, 5.5, and 6, that is the pH. So these are the sample planning. So all 17 samples has been prepared for all three cases to optimize the process parameters for better yield by using these agricultural based. And these are the surface response equations which we got in this case. This is the ANOVA analysis which proposed that very good standard deviation we have of 0.9788 and mean was 0.9515 with a CV of 0.9014. So the similar results were obtained for HS media, beehive, and Zagari waste. Here we can see some surface response plot, incubation temperature, how the incubation temperature affect the yield. So we have started from 25 and we reached up to 35, 25, 30, and 35. So we are getting best result at around 30 and 31 degrees centigrade. If you will see the pH of nitrogen source, these results are for HS media. Then here the increasing trend is there, and 6 pH is showing that at 6 pH the maximum yield of 6.43 is achieved. If we will see the effect of incubation temperature as well as shaking RPM, then we will find the 30 degree centigrade temperature, incubation temperature was found best suitable or optimum for maximum yield, and shaking RPM was around 125. And the similar study was conducted for beehive waste also. So in case of incubation temperature, 32 to 33 degrees centigrade was found best here, and pH was 6 again. In case of shaking RPM and pH of nitrogen source, the pH 5.75 was found optimum in this case. And when we will see the incubation temperature and shaking RPM, the shaking RPM 135 was found optimum in case of beehive waste. For Zagari waste, which is again a very normal or easily available agriculture waste, which is not used for high cost, or you can say the value added products. So if we will successfully conduct this study and this will be available for commercialization, then definitely this will add some income to the farmers who are basically selling the Zagari at very low cost to the buyers. So if you will see the incubation temperature, shaking RPM, you will find that the 30 degree centigrade temperature is found here again best. So in all three cases, we can say 30 to 32 degrees centigrade is best suitable temperature for the synthesis of bacterial cellulose by using this Acetobacter gynum bacteria. And here we have achieved around 10 gram per liter of yield. And if you will see, in case of incubation temperature as well as pH of nitrogen source, then you will find 5.75 pH was found suitable or appropriate to attain maximum yield of bacterial cellulose. So on the basis of this analysis, we can say the optimum yield was obtained 7.01 gram per liter, 9.5 gram per liter, and 11.69 gram per liter in case of HS media, beehive waste, and Zagari waste. So 11.69 is the highest which we have studied in literature, and which is available, make available by different researchers also. The difference in yield from three carbon sources were found by carbon content, nitrogen content, oxygen content in culture media. The carbon and oxygen content in D-glucose, beehive waste, and Zagari waste have been found 67, 60, 55, and 29, 41, 51%. The oxygen content is responsible to utilize the maximum carbon source for the synthesis of bacterial cellulose. The purity of bacterial cellulose has been checked here, and it was found that our bacterial cellulose was also comparable with the FTIR which are available in literature, and all you can say the basic peaks which are responsible to confirm the availability of purity of bacterial cellulose are present here. The analysis for crystal size and other planar spacing with amorphous content we conducted with X-ray diffraction, and we found that at D spacing was 2.22 in case of HS media and 2.225. So this is almost same. So the crystal structure is not changing by changing the media. Crystalline content or crystal size means the dimension of z-axis 12.9 nanometer, 52.05, 66.85. So here the difference is significant. That means in case of Zagari waste, bigger size crystals are forming, but the total crystallinity is less. If you will see the crystallinity content, in case of HS media, the crystallinity was highest 91.17%. In case of beehive waste, it was 89.18%. And in case of Zagari waste, it was 78.06%. Amorphous content was also in the same fashion, means when crystallinity is higher, amorphous content is less. So now the question is this, is the highest crystallinity is suitable or lowest crystallinity is suitable? For making any solvent, solution of this bacterial cellulose, we don't require very high crystallinity. If the crystallinity percent is too high, then it becomes very difficult to dissolve it in any solvent. So 78.06 is quite compatible crystalline content, and this we have synthesized by using Zagari waste is easily soluble in the conventional solvents. This is the EDX, which is attached with the field emission scanning electron microscope, and which confirm the purity of bacterial cellulose as well as the carbon and oxygen content in bacterial cellulose, which we have synthesized by using these based materials. If you will see the morphology of these bacterial cellulose, you will find the average diameter of microfibrils was 7.5 micrometer in case of HS media. And when we synthesized by using the beehive waste, it was 5.8 to 7.4 micrometer. And in case of Zagari waste, the range was 4.2 to 12.8 micrometer. So you can say the fibril diameter was increasing or variability was high in case of Zagari waste. So we have to try to optimize or to try to sync this variation in very narrow slit in further experiments. The FTIR graph of bacterial cellulose, it also confirmed the purity of bacterial cellulose because we got peak at 3278, 29, 25, 16, 40, and these peaks are confirming the presence of OH, CH, CO molecules in glucose chain of bacterial cellulose in powder form. So on the basis of this study, we can make some inferences here. The bacterial cellulose synthesis was done by using 3 carbon sources like D-glucose, Zagari waste, and beehive waste. The optimum yield was obtained 7.1, 9.5, and 11.7 grams per liter. And 11.7 gram per liter yield is too high, which is not reported in literature till date. The yield of bacterial cellulose produced from D-glucose, beehive waste, and Zagari waste has been obtained 3-4 than the standard HS media in static condition. The purity of bacterial cellulose has been characterized by various analytical techniques like FTIR, EDX. The crystallinity of produced bacterial cellulose that was around 78%. So that is best suitable to use this bacterial cellulose for various medical applications also. These are our some future activities. This face mask has been prepared by our student, and this can be used to treat or for cosmetic applications of the human face by bacterial cellulose, which has been loaded by some essential oils and vitamin E. The bacterial cellulose, we are trying to incorporate this collagen to make the bacterial cellulose collagen composite for some other medical applications. So these are some other possible applications of bacterial cellulose. Apart from these applications, some other applications are also possible because n number of applications for bacterial cellulose are available, and people are trying to achieve all these one by one or in one group to another group. So these are some references which you have I have consulted. So thanks a lot.
Right, we can take 1 or 2 questions from the audience. So what if there is, I just want to know,
Sir.
Mukesh, what are the application you are thinking?
Sir, we are thinking to use this bacterial cellulose for some smart bandages because sir, bacterial cellulose has very good holding capacity of any type of drug, plant extract, and essential oils because it gives three-dimensional porous structure. It can hold 99% water apart from 78% crystallinity. 78% crystallinity is there, but still it has the capacity to hold 99% water. And it remains available in hydrogel form also. So moldability is very good, transparency is good. We can mold it any form, we can dissolve after dissolving it, we can cast in any form, and we can store it also. So due to its purity, 100% pure bacterial cellulose, it has been confirmed by other researchers in our study also. There is no doubt in purity. So this is very good option, sir, to be used this biomaterial for medical applications.
So that is your in your plan. It is there that you will take it to.
Yes, sir. Our first object is to mold or to mix this collagen with this bacterial cellulose and to cast some membrane for medical applications.
Medical application. Okay.
Sir, can it be used inside body too?
Sir, basically cellulose is not consumed by our body easily. So it can be used as a carrier because bacterial cellulose is using by a pharmaceutical field to carry the various drugs. So when we will consume bacterial cellulose, it will go out in the same form, but it will carry the drug and it will work properly because there is no toxic effect or toxins are available in bacterial cellulose. So there is no harm to consume bacterial cellulose.
And sir, can the mask with some treatment treat black fungus too? Mucormycosis?
Face mask?
Yeah, the mask you have just mentioned with
Sir,
some treatment, can it treat black fungus, mucormycosis?
Sir, bacterial cellulose doesn't have any medicinal value basically. Bacterial cellulose is a very good carrier. So whatever drug you want to upload, you can upload, no problem. Because number of hydroxyl groups are there. So it has very good coupling capacity. Hydroxyl groups are there, so it means easily you can treat a wide number of medicines or chemicals, which you find that this is suitable for, this is not harmful for human body, that can be uploaded with bacterial cellulose. So bacterial cellulose is not a medicine. Bacterial cellulose is a carrier.
I understand, sir. Thank you.
Okay. Thank you very much.
So thank you, Professor Mukesh.
Thanks a lot.
Now we invite Priya Jaswal. Priya Jaswal is from NIT Jalandhar. So your timing is around 10 minutes. So please stick to the time.
Okay, sir.
Keep some time for questioning also, or some queries. All right. You can start now.
So my screen is visible to everyone.
Yes.
My presentation is visible.
Yes.
Okay, thank you. So good morning, everyone. Myself, Priya Jaswal from NIT Jalandhar. I'm pursuing my PhD from NIT Jalandhar. And from past 2 days, I'm having bad throat. So kindly excuse me for that. So today I'll be presenting on the application potential of coagio textiles in unpaved roads. So these are the contents that I'll be covering.
Ms. Priya, your slides are not visible.
Slides are not visible.
Yes, can you please recheck it?
Okay.
Slides are not moving there. Yeah, now you share.
Now it is
coming on this presentation mode.
Yes, sir. So now it's now I am showing contents.
Content is here. You come in presentation mode. Means full screen.
Sir, it is in my desktop. It is full screen actually.
Okay,
Press
go
shift
ahead.
F5.
Maybe due to some network issue.
F5, F5, F5. Just press F5.
Okay. Sir, it is full screen actually on my desktop.
Okay, go ahead.
Okay, go ahead.
So contents are visible to everyone.
It's visible now.
Okay. So introduction, problems faced by unpaved roads. Then I'll be covering geotextile, surface modification of geotextile, objectives, research material methodology, tensile strength characteristics of untreated and treated coir geotextiles, scanning electron micrograph study, bearing ratio behavior of untreated and treated coir geotextiles, and their impact of chemical treatment on interface behavior of clay geotextile interface, followed by conclusion and reference. So the economic development of any country, it depends on two things, that is education and transportation. So road are the arteries through which the economy pulses. So as per the report on basic road statistics of India published in 2019, India ranks second after USA in the total road network of 58.98 lakh kilometers. Qualitatively, the Indian road network comprises of national highway, state highway, district road, urban road, and rural roads. And as per the survey of by Ministry of Road Transport and Highway in 2017, the 71% of total road network still comprises of rural roads. So the good condition of rural roads, it reflects enormous saving associated with reduced travel time, safety for passengers, and good and timely delivery of local produce. With increase in population, with increase in volume of infrastructure, with increase in, as the peri-urbanization is progressing, and increase in commercial transaction, all these factors has resulted in expansion of road network. So mostly the road network are increasing in order to boost the economy, and in rural areas, rural roads are mostly constructed. So what are basically rural roads? These are unpaved roads, which are also known as a low volume road, in which the sub-base or aggregate layer, it simply lies directly over soil subgrade without any application of any permanent surface coating like bitumen or asphalt. So these pictures which are shown here are the pictures of unpaved road, and we all have seen these roads in our villages in India. So these are rural roads, but there are some problems which are faced by unpaved roads. These are loss of mechanical property with the constant passage of traffic due to extreme weather condition, and along with the time, the mechanical properties of road, it get reduced due to increase of load. The whole structure, it loses its structural integrity, and also the subgrade softening occurs, which results in poor drainage and rainwater infiltration. Since population is increasing, so the soil left is not of high bearing capacity or not of adequate engineering property. So engineers have to construct the road which on the soil which is having low bearing capacity. So due to this, the roads are suffering problem like generation of surface cracks, rutting, potholes, and development of rough riding surface and poor bearing capacity. So all these factors are resulting into increased maintenance cost, and these are further creating some problems regarding for traffic.
Yeah, your slides are not moving.
So I don't know why it is not moving.
We are still in the very first slide.
मैम आप माउस से क्लिक कर दीजिए जिस स्लाइड में बोल रहा हूँ.
So let me.
Now it has moved, saying content has come. Now it is okay.
Yeah, now
Now it is moving.
Now it is moving, sir.
No, now it is moving.
Okay.
we are in third slide now.
Yes, so I covered what are the unpaved roads that we discussed. These are the pictures of unpaved roads. And the problem which are faced by unpaved roads are given here, like loss of mechanical property, increase of load, poor structural integrity, subgrade softening, development of rough riding surface, poor bearing capacity, generation of surface crack, rutting, and potholes. And all these problems further results in increase in maintenance cost, and it hinders the traffic also. Therefore, all these major problems of unpaved road, these can be solved by inclusion of geotextile, which is the quickest and the easiest solution. So mostly the geosynthetics are used, and in geosynthetics also geogrids and geotextiles are used for reinforcement, but I will be covering geotextile. So geotextile for one of the largest group of geosynthetic, which is further categorized into natural fiber geotextiles and synthetic fiber geotextiles. So geotextiles have been used in paved and unpaved road to stabilize soil and improve
Yeah,
their.
it is. I think it is. You are in which slide now?
So I am in geotextile. The slide title is geotextile.
And a slide number is here. Do you have?
No, slide number is not here, maybe.
Because it is in the introduction slide, we can see now only. I think you have moved ahead, but it's not.
Actually, sir, when I am doing full screen, then you're not able to see my slides, I think.
I think now you are. See what we see now. The title is geotextile.
Yes, sir. So I will not do full screen. I will. Can I?
Okay. You carry on the way you want.
Yes, sir.
See at least.
And like this, you will always.
Okay. This is fine. All right.
Okay. So we are covering geotextile. Geotextile have been used in paved and unpaved road to stabilize soil and improve their performance significantly. The major functions which are performed by geotextile in road include separation. So if we can see in both these diagrams, in the first case, the geotextile is not included at the interface of the base and subbase layer, due to which on application of wheel load, the intermixing of all these particles occurs, and which further destroys the structural integrity of whole structure and destroy the draining capacity, resulting in failure of loads. Whereas when the geotextile is used as a separator, it prevents the two particles from getting intermixing, and it maintains the structural integrity of both the layers individually. Next is reinforcement. When the geotextile is reinforced at the interface of base and subbase layer, on application of wheel load, it reduces the normal stress and it absorbs the shear stress which could have been applied on the base layer, and it improves the lateral restraint of the base layer due to the tensile strength of this coir geotextile, and further it helps in improving the load distribution more uniformly. Third one is filtration. In filtration also, the geotextile permit the water flow across the plane with the limited loss of soil particle and provide filtration and increased drainage capacity, which is important to prevent the failure of loads in extreme weather conditions. So coir geotextiles are made up of man-made fiber, geotextiles are made up of man-made fiber and natural fibers. Both of them have their advantages and disadvantages. Like in man-made fiber geotextiles, they have higher mechanical property, but they are uneconomical, less eco-compatible, and they are reduction in the source of raw material due to petroleum products. Whereas in natural fiber geotextile, they are eco-compatible, light in weight, they are abundantly available, relatively low cost, they have low cost, but their tensile strength is not as high as that of man-made fiber geotextiles. So the fiber which I will be focusing will be coir fiber. So coir is a lignocellulosic biodegradable material having a high initial tensile strength due to the high lignin content present in it. Its tensile strength is higher than other bast fibers. So why I'm using coir? Coir I'm using because of its high strength, because of its biodegradable nature, long life. It retains its 20% strength even after 1 year. It is abundantly available in Asian country, and it can be used as a reinforcement with treatment also. So previously, as reported by various researchers, the coir has been used in the form of fibers, braided ropes, hand-knotted coir nets, and woven and non-woven coir geotextiles in paved roads as well as in unpaved roads. So the experimental investigation has revealed that on inclusion of coir in any form, it results in improving the functional and structural performance of the structure. The addition of coir fiber in soil, it increases the compressive strength and stiffness of clay soil. And coir geotextile enhance the California bearing ratio strength of the soil. This California bearing ratio, it is a parameter which decides the load bearing capacity of whole structure. So, but still there are some limitation of coir fibers, and the first limitation is hydrophilic nature. Since coir fiber, its moisture is 10.5%. So in extreme weather condition, when it will absorb moisture, and when it will absorb moisture, then the coir fiber will become more prone to microbial attack, due to which its degradation will get accelerated. And second, this problem further get enhances due to the surface structure of coir fiber. So coir fiber is having the void spaces, impurities, and cracks on its surface, due to which its tensile strength decreases. And when the water get accumulated in void spaces, then the microbial attack, it further get accelerated and degradation starts. Therefore, to make the coir fiber geotextile acceptable and to be used worldwide in unpaved road, the surface modification by chemical treatment is necessary. So surface modification of coir fiber, coir pith, coir yarn, and geotextile has been done by various researchers by using different chemicals. And it was observed that this chemical treatment, they resulted in improved physico-mechanical property, surface property, and in some cases, it also increased the hydrophobicity of the fiber. And when these treated fiber, yarn, or geotextile, when they were included as a reinforcement and used in soil, they improved the soil stability, increased the bearing capacity, improved the stiffness as compared to the soil, which was reinforced with untreated coir. So the main objective of my study is I treated the coir geotextiles with unsaturated polyester resin and bitumen emulsion and methyl-ethyl ketone peroxide, and I studied the physico-mechanical property and surface morphology of untreated and treated coir geotextile. Study the influence of untreated and treated coir geotextiles on the interface property of clay and coir geotextile, and studied the bearing capacity behavior of sand overlying clay with woven and non-woven untreated treated coir geotextile at the interface. So
Priya, you have to go very fast. You have another 2-3 minutes. You have to complete now.
Okay. So the material that I used was the woven coir geotextile and non-woven coir geotextile of two different GSM. They were coded as W1, W2, and NW1 and NW2. So the soil which I used was bentonite clay. The reason for using this type of clay was it is a very weak soil due to the montmorillonite chemical compound present in it. It is a soft soil. And sand which I used was the local sand available in Sundarnagar. The chemicals, as I told you earlier, were these. Based on this box and Mencken factorial design, the chemical composition was decided, and the fibers, the coir geotextiles, were treated based on these chemical compositions. And to evaluate the effectiveness of the treatment on coir geotextile, the wide width tensile strength test was conducted as per ASTM D4595. So these are the pictures of untreated coir geotextiles, and these are treated coir geotextiles. So after testing the wide width tensile strength, so these were the curves that were obtained. So these were for warp wise and weft wise, and this one is for W1, and this one is for W2. This one is for treated W1, this one is for treated W2. So we can see here that the tensile strength of treated coir geotextile has increased as compared to untreated coir geotextile, and this is mostly due to the strong, and this is due to the high adhesive nature of unsaturated polyester resin and bitumen emulsion. It created a strong adhesion between coir fiber. As a result, the fiber surface, it get improved, and it resulted in increased tensile strength. The void spaces of coir fiber, they were filled with the chemical, due to which they were acting as a plane of weakness, but after chemical treatment, the surface area also get increased, and the tensile strength of whole coir geotextile was improved. This can be easily visible in these two same images. So this image is of untreated coir fiber, which is having impurities, cracks, and void surfaces. And this is the same image of coir fiber when after chemical treatment. So these imperfections didn't contribute positively to the load bearing capacity of sand overlying clay. But after treatment, the surface of coir fibers is free from surface debris. It was covered with the layer of chemical, all the void spaces were filled up, and due to which the surface area also increased, and also the tensile strength of geotextile also increased. Next, I performed the test, which is a California bearing ratio test. So this was the this is the apparatus that is used, and the test is conducted in two conditions, that is soaked condition and unsoaked condition. In soaked condition, this is a sample that is prepared. In soaked condition, the whole sample, it is soaked for 96 hours in water, and after that the testing is done. So by performing this test, the curve which is obtained is low deformation curve. So this we are getting, the dotted line is for untreated geotextile and the solid line is for treated coir geotextile. So we can observe here also, when the treated coir geotextile was included at the interface of sand overlying clay, then the load bearing capacity was increasing as compared to untreated coir geotextiles. And these curves, these curves which are shown behind at this point that I'm showing you, these are the curves for soaked condition. In soaked condition, the load bearing capacity is low because soil is very wet and the friction is very less. But here also,
You come to a conclusion now, Priya.
Okay, sir.
Is running out now. Yes.
This was the direct shear test that I conducted also. This direct shear test is to determine the interface friction behavior of the geotextile and clay. At the interface, this test was conducted. And here also we get the curve of shear stress and shear strength. And here also the treated geotextiles showed the positive result as compared to untreated coir geotextiles. So conclusion is, so treated woven and non-woven coir geotextile, when they were placed at the interface of sand overlying clay structure, they can be useful in unpaved road in improving the bearing capacity, especially in those situations where the rut depth is very high, as the improvement in bearing capacity was realized up to a large deformation. Further, it is evident from the finding and discussion discussed above that the treated coir geotextile have the capacity to serve a useful role over the soft soil in unpaved road. And coir geotextiles are expected to improve the pavement behavior over time, likely by filtration, drainage, and separation. And as the coir products are produced in rural area, so their use in unpaved road will provide a great boost to the construction as well as maintenance process. So these are the references that I consulted. Thank you, everyone.
Any question from anyone? Okay, thank you, Priya.
Thank you so much, sir.
Sir, one question is there that coir is useful in say Kerala, etc., but in other areas like foothills of Himalaya, can pine, etc., be used?
Yes, the pine can also be used, but coir is not only, I have not only focused in India, also in other Asian countries, also like Indonesia, also the production of coir is very high. So keeping that in view, I have used coir, but we can use pine also, but we have to study what are the properties, whether we can use it in a geotextile in the road or not.
Thank you.
Okay, thank you, Priya.
Thank you so
Now
much.
we move on to the next speaker, Muthu Kumar and Muthu Kumar from PhD College of Technology, Coimbatore.
Is
So,
my
Dr. Muthu Kumar,
slide
please.
visible, sir?
Yeah, it is visible, but please stick to the time. You have to finish in 10 minutes.
Okay, sir.
All right.
Good afternoon. I am Dr. N. Muthu Kumar, Assistant Professor from Department of Textile Technology, PhD College of Technology. My presentation topic is study on influence of fiber blend ratio and bonding techniques on thermal insulation biodegradable banana recycled PET nanomaterials. So introduction, textile industry is one of the most polluting industries in the world, and it is causing a greater impact on the environment. As the waste generation is getting increased day by day, the sustainability concepts are the need of the hour in every part of the industry. Since sustainable manufacturing methods will possess no or very little harm to natural resources, the implementation of the concept can reduce the environmental pollution. In the last few years, natural and recycled materials are considered effective raw materials for producing technical textile materials at a reduced cost. They are becoming increasingly very popular thanks to many important advantages like low mass densities, cell structures, low thermal conductivity, no harmful effect on the health, then large availability and sustainability. So in this work, we have taken banana fiber for non-woven development. The reason is banana fibers are available in abundance in various countries. These are all biodegradable. These are cellulosic fiber obtained from pseudostem of banana plant, which is an agricultural waste and usually thrown or used as a compost. So the main objective of the study is to develop needle puncture and chemical bonded non-wovens by blending banana fiber and recycled polyester. Banana fiber is agricultural based and recycled polyester is textile based. Then to characterize the physical and thermal insulation properties of the developed non-wovens. Then to analyze the effect of blend proportion and bonding technique on thermal insulation performance of developed non-woven. Finally, to analyze the biodegradability of the developed non-wovens. So this is a work plan. First, we sourced the banana and rpet fiber in and around Coimbatore. Then we prepared, then we blended the fibers in 3 blend ratios: 90% banana, 10% recycled polyester, 70%. Then development, we prepare the carding web. Then we manufacture the non-woven by using 2 different techniques. One is needle punching, another is chemical bonding. Then we characterize the developed non-wovens in terms of GSM, thickness, density, and air permeability. Finally, evaluate thermal insulation property of the developed non-woven. Finally, the biodegradation. So the properties of sourced fibers, banana and recycled PET. Then we prepared the carding webs in miniature carding machine. Then after the carding web development, we prepared needle punching and chemical bonding. The needle punching was carried out in Delo needle punching machine with a punch density 150 and penetration depth of 10 mm. So these are the developed needle punching non-ovens. The next, chemical bonding. For chemical bonding, we use latex as the bonding agent. Then we sprayed over the web. Then we maintained the odd on percentage, 20%. Then after that, the web were calendared. Then they are dried at 60 degrees Celsius for 30 minutes. So these are the steps in the chemical bonding. So these are the developed chemical bonded non-ovens. So coming to the character of the developed non-ovens. Here you can see thickness, GSM, density of the both needle punch chemical bonded non-ovens. So the developed non-ovens have thickness in the range of 3.93 to 4.2 mm. The GSM around 420 GSM to 462. The densities are around 0.104 to 0.110. So coming to the air permeability, here you can see the air permeability values, the needle punch and chemical bonded non-ovens. Here the part of the blue color shows the needle punch, the brown color shows the chemical bonded. So while comparing the blend ratio in the both the methods, needle punch chemical bonded, the 10% banana rpet non-ovens have better air permeability compared to other blends. Then while comparing the bonding technique, the chemical bond non-ovens have better air permeability compared to needle punch non-ovens. So this is the thermal resistance value of the developed non-ovens. Here you can see the blend ratio among the 3 blend ratios. The 90-10 banana recycled PET non-oven have better thermal resistance value in both the cases, needle punching and chemical bonded non-oven. While comparing the bonding technique, the chemical bonded non-oven has better thermal resistance value. The thermal resistance value in the range of 0.25 to 0.3 meter square Kelvin per watt. So it was observed among the blend percentage, 90-10, 90% banana, 10% recycled PET, better thermal resistance value. It may be due to higher proportion of the banana fiber. The banana fiber has inherently hollow structure. Again, compared to recycled polyester fiber, the banana fiber have lower density and a higher diameter. So while comparing the bonding technique, the nanowoven made by chemical bonding has the loose structure compared to needle punch nanovens. In chemical bonding, the role of the binder is simply to bond the fiber together to achieve an increase in network strength, and the substrate is not compressed and the original bulk and post structure web is maintained. Hence, they have a slower heat transfer rate and increase in thermal insulation value. So the nanovens made by chemical bonding technique have 6.69% higher thermal insulation value compared to needle punch nanovens. Then we analyzed we developed a hybrid structure. We have developed two samples by using chemical and needle punch nanoven. For this, we have taken 90-10 banana recycled PET nanovens. In the first sample, we kept chemical bond at the bottom and needle punch nanoven at the top. In the sample two, we reverse. That is, needle chemical bond nanoven at the top and needle punch nanoven at the bottom. So while analyzing the results, the first sample, that is a chemical bond on the top, bottom, and a needle punch top has better thermal insulation value. That is 0.43 meter square per Kelvin watt compared to the chemical bond on at top, that is 0.355. So finally, we have carried out biodegradation study. So the biodegradation studies are carried out as per ISO 11721 2003 standards. For this study, we kept the samples in the soil for at the 8.5 centimeter depth. So during the different periods of degradation, distilled water was added to the sample to retain the moisture content of the sample. After every 5 days, fabric which is buried under the soil is taken out. The samples were rinsed with the distilled water for approximately 10 minutes and dried under standard atmospheric conditions. And the dried samples were analyzed quantitatively. So these are the biodegradation. We have carried out 4 weeks. So this is the biodegradation of the needle punch nanomens. So while comparing the among three, the nanoven 90-10 has a better degradation compared to 70-30 and 50-50. So this is the biodegradation of chemical bonded nanoven samples. Here also the 90-10 has better degradation compared to 70-30, 50-50. Then compared to needle punching nanoven, the chemical bonded nanoven has lower degradation. On the biodegradation cells, the chemical needle punch nanoven has 90-10, 22.64%, but chemical bonded nanoven has only 19.29%. The chemical bonded has lower degradation. It may be due to the presence of latex we have used for chemical bonding. Finally, conclusion. So in this work, the nanovens were developed in 3 blend ratio, 90-10, 70-30, and 50-50, using both needle punch and chemical bonding. The nanoven from made from 90-10 or banana recycled PET has higher thermal resistance value compared to others in both the needle punching and chemical bonding technique. The nanovens made from chemical bonding technique had better thermal resistance value compared to needle punching nanovens. It may be due to the porous and bulkiness. The hybrid structure developed by keeping chemical bonded nanovens the bottom layer, the needle punch nanovens the top layer had better thermal resistance value. So the banana fiber present in the nanoven will be degraded almost within a period of 5 months, and the remaining polyester fiber can be recycled. So the nanovens developed in the study are low cost and environmentally friendly and can be used for building insulation applications. Thank you.
Okay. Thank you. Now, if there is any questions or queries from anyone or any comment. Dr. Muthukumar, I have a question. Why did you measure the air permeability? What was the idea?
Maybe the porous nature of the sample. Hello.
Sorry. Yes. Once more.
To study the permeability properties, like how the structure is porous.
So that. Hello.
Yes, sir.
Permeability property.
Yes, sir.
Did you measure the porosity or not?
We are not measured porosity, sir.
Not measured porosity. Okay. All right. Any question for anyone? Since there is no more question, so thank you, Dr. Muthu Kumar,
Thank you,
for
sir.
your presentations.
Okay,
Now,
thank you.
we go to our last speaker of the session, Manu Agarwal.
Good afternoon, sir.
So Manu Agarwal is from NIT Jalandhar.
Yeah.
Please,
Is my screen is visible?
Yeah, you are visible now, not slides.
Okay, sir. Wait a second. I will share my screen.
Your screen.
Is my screen is visible now?
Not yet. Now it has come. Yes.
Okay. Thank you, sir.
So stick to the time. No? Just take 10 minutes.
Yes, sir. I will try my best.
So straight away you can go to the objective of the work and methodology and then results.
Good afternoon, respected professors and all delegates. I am Manu Agarwal, pursuing PhD from NIT Jalandhar under the supervision of Dr. H. Chatterjee. Today I am here to present my one part of my PhD research work based on composite entitled Effect of yarn parameters on the static and dynamic properties of jute yarn reinforced epoxy composites. Introduction. In today's era, sustainability and biodegradability are the two important factors that are essential in many engineering areas pertain to composite materials. Composite basically is the combination of the two materials that combine together to produce a material with a better properties and can be used in a very wide application such as automobiles, aircrafts, and building components. And these materials serve as specific purposes and exhibit desirable properties. The main advantage of the composite materials are their high specific and stiffness to a low density ratio when compared it with to the bulk material. As a reinforcement material, as opposed to the synthetic fibers such as glass fiber, carbon fiber, natural lignosulfuric fibers are expanded in today's scenario due to the various advantages such as less cost, easy availability, biodegradable, flexible for processing. Besides these advantages, natural fibers also offers many technical advantages such as good tensile and flexible modulus, and also the desirable aspect ratio. In this work, here I am using a jute yarn, single ply jute yarn having a TD3 grade as a reinforcement material that having a 58 to 63% cellulose component, and for the matrix element, epoxy resin system is used. Fabrication process of composite. For the fabrication of composite, here hand layup technique is used, where initially the epoxy resin and the hardener is mixed in a ratio of the 10:1 and sonicated it for 10 minutes at a 20 degrees Celsius. And prior to the molding, the jute yarn also wound on a frame at a constant pressure tension, and then these wounded jute yarns are integrated into the resin using a steel mold. After that, the top plate of the mold is covered, and 10 kilonewton force is given to the mold so that the excess resin is squeezed out. And then the mold is kept for 24 hours at a room temperature. The pre-curing of the composite sample is done for 4 hours at 100 degrees Celsius, followed by the post-curing for 2 hours at 80 degrees Celsius. The composite samples are cut according to the tensile and DMA testing of the composite material. Composite samples are prepared according to the 3-variable, 3-level box Banneker experimental design, where jute yarn count, orientation of jute yarn, and mass fraction of the jute yarn are the 3 variables. 4, 8, and 12 pound per spindle jute yarn is used for the fabrication of the composite, and yarn is bounded on a frame with respect to the direction of the longitudinal of the mold at a 3 angles, that is 0 degree, 45 degree, and 90 degree. Characterization of the jute tensile testing of the jute yarn is testing according to the ASTM D2256. 50 tests of each sample is carried out. As jute yarn is a natural fiber, it has a high CV percentage, so 50 samples per yarn is carried out. For the tensile testing of composite, ASTM DC38 is used and the samples are cut into a dog bone shape. For the dynamic mechanical analysis of composite, DMA1 is used, and in DMA1 is used using a 3-point bending mode. So result and discussion. Tensile testing of a jute yarn. Firstly, I will discuss the tensile properties of the jute yarn. It is observed that with increase in the count of the yarn, elongation percentage and breaking force increases, while tenacity and the initial modulus shows a different trend. 8 pound per spindle yarn per spindle jute yarn shows the maximum tenacity and initial modulus, as tenacity is the ratio of the breaking force and linear density of the yarn. With increase in the count, the consequent increase in the breaking load of the yarn is higher as compared to the change in the linear density, while goes from the 4 to 8 pound per spindle. Further increase in the count, there is a downward trending shown in both cases, tenacity and the initial modulus, where the linear density change in the linear density outweighs the effect of the enhancement of breaking load of the yarn. So 8 pound per spindle yarn has a maximum tenacity and initial modulus. So effect of count on the composite material. Storage on a tensile and the storage modulus of the composite. The tensile strength as well as the storage modulus of the composite basically depend upon the type of reinforcement used, mechanical properties of the reinforcement, mass and the volume fraction of the reinforcement, and the interface between the resin and the reinforcement material. It is observed that with the incorporation of the jute yarn, the tensile strength as well as the storage modulus of the composite enhanced. Further, among all the composite, 8 pound per spindle jute yarn reinforced epoxy composite shows the maximum tensile strength as well as the storage modulus, that is 45.86 megapascal, and storage modulus is around 5.87 GPa. The strength of the composite mainly depend upon the three factors, that is tenacity of the reinforcement material, twist per inch of the yarn, and the number of yarns in the composite. With increase in the maximum tenacity of the reinforcement material mainly depends the resultant property of the tensile strength of the composite as well as the storage modulus of the composite material. Also, with increase in the twist per inch, also with increase in the count, twist per inch also decreases, which leads to the better impregation of the resin, has good interface addition between the yarn and the resin system. Moreover, with increase in the count, number of the yarns also decreases, hence less area of the interface between the resin system and the reinforcement material. As a result, here it is the interplay of the three factors, that is tenacity, TPI, and number of yarn, that decide the result and properties of the resultant properties of the composite material being fabricated. So here is the parameter and responses of the composite material that we have fabricated. 17 according to the box Beneken design, total 17 run has been done, and the composite that is fabricated with the 8 pound per spindle yarn at with 20 mass loading weight percentage at 0 degree shows the maximum tensile strength and the storage modulus. Now, influence of direction and mass loading percentage on the tensile strength of the composite. Here I am showing the graph of the composite that is fabricated with the 8 pound per spindle jute yarn. As earlier, I will show the effect of the count on the composite, and the result shows that the 8 pound jute yarn the composites are fabricated with the 8 pound jute yarn shows the maximum result. So from this graph, it is clearly shows that with increase in the mass loading fraction, the tensile strength of the composite increases. With increase in the weight percentage, as with increase in the mass loading fraction, the tensile strength of the composite increases. As the number of yarns increases with increase in the mass loading weight percentage, hence there is a more area of interaction between the reinforcement material and the epoxy resin. Also, with increase in the reinforcement material, that is a jute yarn, the yarn effectively as the reinforcement material resists the crack propagation. So not only the matrix material that influence the strength of the composite material, also the reinforcement material also influences the tensile strength of the composite material. So with increase in the mass loading percentage, the interface between the resin and the reinforcement material increases, which increase in the tensile strength of the composite. Moreover, this graph, at orientation of the 0 degree, the maximum tensile strength of the composite is found, as though the load is applied in the longitudinal direction, and the orientation of jute yarn at a 0 degree contributes the maximum stress transfer, which results in the better tensile strength. While at the 45 degree and the 90 degree, the jute yarn is wound across the direction of the applied force, which does not contribute to the stress transfer from the reinforcement material to the resins, to the epoxy resin. Hence, the tensile strength of the composite decreases. Likewise to the tensile strength of the composite, storage modulus of the composite is also maximum at the maximum mass loading fraction, that is 20 weight percent, and 0 degree, and the 0 degree orientation of the angle wound on the jute yarn. So conclusion of my work is the tensile strength and the storage modulus of the composite shows the at different count shows the increment with increase in the count up to the 8 pound per spindle jute yarn. Further, it decreases. The maximum tensile strength and storage modulus shows the maximum values at 0 degree orientation of the jute yarn that is wound on a frame with respect to the longitudinal direction of the mold. With increase in the mass loading of the jute yarn, the tensile and tensile strength as well as the storage modulus of the composite enhanced. So from these properties, we can predict it that the composite that we fabricated with the jute yarn and the epoxy resin can be engineered for the various applications such as automobiles and building components. Thank you. So this is.
Thank you,
Thank you, sir.
Manu. Now I leave it for some questions or queries or any suggestions for anyone. I have a question. Why did you measure storage modulus?
Yes, sir.
Why did you measure storage modulus?
Sir, I have studied the dynamic mechanical analysis of the composite where storage modulus is studied.
Okay, that is okay. Why have you done it? What is the practical utility of storage modulus? Keeping in mind some applications of the composites that you are going to make.
Yes, sir. Actually, it is related to the dynamic mechanical properties, so that we can see how can the how much modulus is stored in the composite when we when any reinforcement material is reinforced in the polymer in a polymer.
Modulus is stored.
How much energy is stored in the composite?
Okay, which energy?
Sir, in the form of the modulus, flexural modulus, bending modulus, sorry.
Plus is not energy. Yes, it's not energy. Okay, any other questions for anyone? Okay, then if there's no more questions, then I thank you. Monu, you can for your presentations.
Thank you, sir.
So I thank all the audience also for being with us.
Thank you so much.
Thank you, everyone. I would like to thank you all the speakers for such a beautiful talks. And most importantly, I would like to thank you, Professor Chattopadhyay, sir, for handling the session so beautifully. Thank you, everyone. Now the next session will start at 2 o'clock, the plenary lecture. So we will meet at 2. Thank you.
Thank you.
So you can leave if you want. It will
Yeah, I
start at 2. Yes.
Leave and join again.
Yes, sir, you can.
Right.
Niranjan, please move.
Good afternoon, sir, and good afternoon, everyone. Welcome to the session 6, Functional Textile. Myself, Vanna Kumari, the coordinator of this session. I would like to welcome our Honorable Session Chair, Vikas Chatra, sir. He is President of Textile Association India of Delhi Unit, as well as he is CEO of Sofocor. From here, I would like to hand over this session to our respected chair. Sir, over to you.
Thank you. This is the session where we're talking about the functional textile, and we have a few eminent speakers with us. First, I would like to invite Professor R. Chattopadhyay. He's professor in IIT Delhi, where his area of interest is engineering textile products, quality and process control, and pressure garments. This is something new which I also like to understand from Professor Raab. And he's got a lot of awards into his kitty. He's got Best Oral Paper Presentation Award in RUTAC 2018. He is the recipient of Monbushu Scholarship Japan, and he's an Eminent Engineers Award in September 2014 by Institute of Engineering. I hand over to Professor Chattopadhyay, and would request you to please stick to your time. What's been is there till almost 25 minutes is with you. Of course, 3 minutes has been already taken by us. So you have 22 minutes still left. Over to you, sir.
Okay, thank you. So let me share the screen first. Can you see the screen now?
Yeah, it's visible.
Fine. So I'm going to present a talk on this particular topic, that is liquid moisture transferred by advanced profile fibers. Liquid transport in fibrous assembly. There are two ways in which actually the liquid is transported in any fibrous assembly. That could be in-plane transport, which is along the fabric plane, and there could be transverse transport, which is across the fabric plane. Both the types of transport is important depending upon the applications of the textile material. Now, what causes the liquid to move spontaneously on fibrous surface? The reason for this is the capillary force. And the capillary force actually acts in the small capillaries which are formed by the fibers. Between the fibers, there are spaces. And these spaces are basically capillary spaces. And these micro spaces are responsible for driving the liquid. There is no external force. There is no pump. But the liquid still moves. So it is the capillary force that is generated because of the surface tension of the liquid that causes the liquid to move. And this has an immense significance in many textile products. Now, as I said, any textile fabric, whether it is woven, knitted, non-woven, or braided, whatever we say, is basically there are a large number of capillaries within the fabric. These capillary channels exist between the fibers. And any fabric is a complex network of capillaries. The capillaries varies in shapes and sizes, depending upon the cross-sectional shape of the fibers. The dimension of the fibers may change from one end to the other. And capillaries are mostly discontinuous in nature, especially when a yarn is made from stable fibers. However, if I make a yarn from the filaments, the capillaries will be continuous in nature. Capillaries are also interconnected, and the capillaries follows a tortuous path and may branches out. That means that in the case of, let us say, spun yarn or filament yarn twisted, the fiber themselves also keeps on moving from surface of the yarn to the interior part of the yarn. And therefore, the capillaries also follow a very, very tortuous path, which is very difficult to define exactly. It also, the spatial arrangement of the capillaries depends upon the degree of orientation of the fibers or the filaments in the yarn and position of the yarn in the fabric. So that's all about the capillaries that we have. That means in the fabric, there are a lot of channels through which the liquid can move. And these channels are not really well defined in terms of their geometry. The geometry is very, very complex. So what happens capillary geometry? Generally, what matters in this case is the diameter of the fiber, that is the denier of the fiber that we choose, the fiber cross-sectional shape. Most of the natural fibers are basically non-circular. And in the case of synthetic fibers, there are many fibers which are circular, and we can also generate different types of shapes depending upon the cross-sectional shape of the spinneret that is used to spin the fibers. So various kind of shapes are available nowadays with these synthetic fibers. Fiber dispositions within the yarn also can matter and affect the capillary geometry, that is the orientation of the fibers or the level of twist that we keep in the yarn, or yarn disposition within the fabric, how the yarns are interlacing. That also can matter in the case of plain weave or satin weave or free weave, basket weave. The yarn interlacement patterns are different, or there are so many types of knitted structures also. So disposition of the yarns within the fabric will also can affect this geometry of the capillaries. Inter-yarn spaces in the fabric itself. Because between the yarns also there is a chance of capillary formations. If the yarn, because the yarns are very close to each other, so the gap that exists between the yarn is also a source of capillary formations. So what we are trying to study in this particular presentation is that we're considering three more important type of cross-sectional shapes which are nowadays available, and they are basically used for high wicking, developing high wicking garments, especially for in the area of sports garment. So what we are trying to do here, the first of all, that filaments should be characterized, and after that the yarn wicking has been studied, and followed by that the fabric wicking also has been studied, just to know how the liquid moves. So the kind of cross-section that has been chosen to study this, one is 4DG polyester fibers. We all know about them, the cross-sectional shape. It's a very complex shape these fibers will be having. The hollow polyester fibers, and the other one is octalobal polyester fibers. So these three types of fibers actually have been used for a particular study, and these fibers were characterized in terms of their cross-sectional geometry, where the fineness of the fibers of 6 denier is quite heavy in terms of denier, and the tenacity elongations values are given, which are normally what is commercially available. So now from there, we try to find out the parameters which are relevant from the point of view of capillary formations. Now, if we look at this fiber, hollow polyester fibers, it has an overall diameter of 32 micrometer, and it has a hollow, and the hollow part is around 12.6 micrometer. So it is only one hollow channel is there inside the fiber. The 4DG fiber, roughly it is rectangular in shape. If you look at the boundary of this, and it has the length, you can say roughly 47 micrometer, and the breadth is 34 micrometer. And then we have octalobal fibers, where there are 8 different lobes, and we can look at this, the lobes, the dimensions are 28.1, and overall diameter of the fiber is 29.58 micrometer, close to 30. So anyway, if we compare these three fibers, then in the case of 4DG, the number of capillary channels that exist on the fiber surface. So these are the channels. This is one channel, this is one channel, this is one channel. Generally, it is 5 to 6. In the case of hollow polyester, we have only a single channel on the side, that is at the center of the fiber. In the case of octalobal, since there are 8 lobes, there are 8 channels. And each of these channel dimensions are also stated in this table. So because these channels are basically will be transporting or carrying the liquid from one point to the other point. From there, using these fibers, some yarns are made and then some fabrics are also produced. So typically the yarn counts are kept constant at 38 ticks. The twist level also is kept constant. And the fabrics are made of a GSM, which is around 160 or close to, you can say, close to 160. Now, first of all, the fabric surface wettability was checked, and what was found, which is stated and shown in this particular diagram, that all the fabrics are wettable. But the contact angle, if you look at, which is 4 dg, it is around 45.2 degree. In the case of hollow polyester, it's 58 degree. And in the case of octolobal polyester fiber, 36.4 degree. That means octolobal polyester fabric shows better wettability in comparison to the other two. Now, if we look at the liquid movement within the yarns, which are shown here in this diagram, and we'll see that, see here, the one is the wicking test that has been done, vertical wicking, the single yarn, in order to understand how quickly the liquid will be picked up by the yarns, by the capillaries within the yarn. And this was done for single yarn as well as for 2-ply yarns. And if you look at this, the orange diagram belongs to octolobal fibers. So octolobal fibers actually, initially, all the yarns are showing similar behavior. But in the end, we can see that the octolobal yarns are actually gaining much better wicking height in comparison to the rest two. And if we look at the plied yarn and single versus plied, if we compare, because many a times you may think that instead of single, if we go for plied, does it make a difference? It makes indeed a lot of difference. If you check the wicking maximum height attainable by a double yarn, the plied yarn, it is much more. If you see, look at this height, it is 150 mm or more. Whereas for the single yarn, it is hardly around 70 mm. It is between 60 to 70 mm. Whereas for the plied yarn, the same yarn plied together, the wicking height rises phenomenally, and it also almost becomes double. So that's a big change, that if we go from single to ply. And what is happening, the question is why the wicking height suddenly increases so much because of this plying action. That because first of all, see, additional wicking channels is created when two yarns are plied together. Like here I am showing, these are the places where triangular wicking capillary channels are formed. And from this also the liquid can wick very fast. At the same time, sometimes depending upon the level of twist that we choose in the single and ply combination, there are cavities which are formed between the yarns. These cavities act as a storage of liquid, and that helps to wick it further. So as the liquid moves, then space available between the yarns, if at all is available, sometimes it is available, the liquid can get stored there, and it will help to wick faster and longer. As a result, the plied yarns show they attain a wicking height which is much more than the single yarn. Then the wicking in the fabric also we have studied. So this shows the stages of the flow of the liquid in the fabric, and these are the video images. From the video images, these are the static images which are taken, and what we see here, that this is the beginning of the very stages of flow. This is the beginning. What we see here, the liquid has just started getting inside the fabric. This is the second stage. This is the third, and this is the fourth stage. So initially, if you see that the red colors indicates how the liquid is moving. So there are certain channels, micro channels through which the liquid is moving, but all the channels are not filled up with the liquid. So wherever the channels are basically straight and quite oriented, these channels carry the liquid faster, but there are many other channels which takes time to absorb the liquid and then carry them forward. So this is how the movement of the liquid within an open fabric takes place, and with time, more and more liquid will flow because of the capillary pressure, and gradually all the yarns that we have, the spaces that is there within the yarn, they will get filled up with liquid. Not only that, the spaces that we have between the liquid, between the two yarns, like here and here, is not very clear in this image, but we have seen it, that those spaces are also filled with a lot of liquid. That means the capillary channels are getting formed between the yarns also, and they are equally effective in carrying the liquid forward or spreading the liquid over the entire plane of the fabric. Then another study which was done, that is the dynamic micro-liquid transport in the fabric, and where a drop of liquid was placed on the fabric, and how this liquid drop is getting spread out over the top surface of the fabric, as well as it goes down and then gradually started spreading out at the lower face. So what happens? The liquids spread out outwards on the upper face of the fabric first, followed by part of the liquid will pass through the fabric from the upper to the lower surface, and then as it appears in the lower surface, it starts spreading over there. So therefore, and this is everything is happening because of the channels, that is the capillary channels that is there in between the fibers and between the yarns. So here there is shown there is a drop of liquid right now, and gradually this drop will vanish and you will get a watermark as we see it here. That means this part of the fabric is filled with water, and the other face of the fabric will also have some liquid. So this study actually gives us an idea of how the liquid is transported from one face to the other face. This kind of transportation of the liquid is very important, especially in the case of sportswear, where we need to remove the sweat from the skin and take it out from the inner surface of the sports garment to the outer surface, so that they can be dried very fast through evaporation process. So if we look at this now and this table, then the last part of the table is not visible. If you look at these data, that is wetting time, absorption rate, maximum wetted area, spreading speed, these are the parameters which are studied by using an instrument. And if we look at this data will show that in all the cases that the fabric made using the octalobal polyester fiber is giving much higher values in comparison to 4-DG polyester or hollow polyester fibers. Waiting time is much less in the case of the fabric made from octalobal polyester fiber. Absorption rate is also higher. Maximum weighted radius is also more. Spreading speed is also higher in the case of octalobal polyester fibers. And based on this, these are the video images of the liquid movement of the two surfaces that is again, and you will see that the blue surface indicates the spreading of the liquid. So this is the top surface and this is the bottom surface of the three types of fabric that has been used. And the blue one and you see that the material, the liquid is there on the from top, it has gone to the bottom. So bottom surface also show a lot of blue area, And the area where it is dark, that is black, it means this space has not really, no, the liquid is not there due to some reason. Otherwise, lot of liquid has been transferred from the top surface to the bottom surface. And this particular, no, actually whatever we have seen in the previous table, the same data has been plotted here, is nothing new. So it is just showing that the performance of the 3 different fabrics made from 3 different fibers. And if we look at the value of overall moisture management capacity index, you will see that the octa-level fiber gives you a value of 0.59, which is higher in comparison to 4DG or hollow polyester fiber. The same data is plotted here, that is overall moisture management coefficient is maximum for the octa-level fibers, that is fabric made from octa-level fibers. Now, sometimes we may feel that what happens that if we mix 2 filaments, both are basically meant for very high wicking rate. Now, the question is whether 2 high wicking filaments improve wicking further or not. So that study was done where octa-level polyester was filaments and 4DG polyester filaments are taken together and twisted. Similarly, octa-level and hollow polyester filaments are taken together and twisted. The yarns are made and the studies were conducted. And it was found that not necessarily that by taking 2 filaments together and twisting them together will improve the wicking properties. Sometimes what may happen that in this case, it was found that blending of or mixing of 4DG polyester and octa-level polyester fiber may cause the lobes of both the fibers to intermesh, and each of them therefore blocking the surface capillaries of the individual fibers. So what happens that the surface capillaries which are there in the case of 4DG fibers and the surface capillaries also exist in the case of octa-level fibers. So when these 2 filaments are taken together and twisted, what happens that there is a intermeshing, and therefore what happens that some of these surface capillaries are blocked completely, and therefore the movement of the liquid becomes slower. So that possibility may exist. So if we take a non-circular fibers, either 4DG or maybe octa-level, we can probably mix it with a hollow fibers, so a hollow, hollow and round polyester fibers. Then this possibility of the lobes getting blocked will not be there, and therefore the wicking behavior will be always good. But otherwise, this possibility could also exist. Then there's another study was done just to know that if the polyester coarse-spun yarn is made, where we can have polyester filament, which is octa-level polyester filament was taken at the center, and on the surface they were basically polyester stable fibers, and the yarn was made so that we get a spun look, we get a soft surface, and also we have very high wicking rate. And the hairy surface can help us because it has the ability to wick the liquid by the projecting hairs, especially if it comes into contact with the skin. Then these hairs can also help in sucking or wicking the liquid from the skin into the yarn, and then within the yarn, once it enters, once it goes to the filaments, then filaments will be able to carry the liquid very, very fast, because the channels which are there here are not only there on the fibers, so these channels will be able to carry the liquid very, very faster. So we can have the advantage of a spun loop, a soft surface, and a high wicking possibility. And that was what was done, and the yarns were made and tested for wicking behaviors. And in the case we see that both vertical and horizontal wicking was tested, and it was shown that the coarse spun polyester That is why we had the filament in the core is giving you much better wicking. And not only another interesting thing that vertical wicking and horizontal wicking, in both the cases, the distance to which the liquid is transported is almost same. That basically means there is no difference between these two, especially for these yarns, because we have used a fiber which is very high performance fiber in terms of wickability. And the lower image shown that these are the filaments, octalobal filaments. It is carrying the liquid very fast, you see. And on the surface, these are the polyester staple fibers. So they take time to absorb the liquid and carry them forward, because capillaries formed by the staple fibers are disjointed in nature. They are following a circular path, and there may be some migration also between the fibers. So the capillaries are not very straightforward, and therefore it takes time for the liquid to move. So the conclusions now is that in fabric wicking, both micro and macro fluid transport phenomena are involved. Octalobal cross-sectional shape shows best wicking performance when you compare between octalobal 4DG and hollow polyester fiber. The other thing is the plied yarn is better than single yarn in wicking ability. Sports punch polyester yarn shows excellent wicking and therefore very suitable for high active sports where the person is going to sweat or perspirate. A lot of sweat will be generated, so this may help. And while trying to maximize the wicking performance, one has to be careful regarding choosing the filament cross-sectional shape. We have to make sure that the channels, the bloody channels which are there on fiber surface, they should not get blocked. So with this, I close this particular talk, and I am ready for some questions, some queries, whatever you have. Thank you.
Thank you, Professor Saab. I have one question with this regard.
Yes.
I hope it's not been some chemical finishing is not done with this all testings.
No, no chemical. No, we have not done any chemical finishing. No.
No chemical finishing is been.
No.
So, with your experience, what do you feel? How much the chemical can impact or increase the moisture wicking?
See, these whatever finishes in this case, it has already been done by the manufacturer itself.
Because why I am sharing this, I had been passed into the same field in the rice chemical industry, and lot of queries from the customers were always there, and we were struggling to get, like Gap was asking for 15 centimeter height in 30 minutes, which we most of the time failed out with the chemical help. And unfortunately, we never gone backward. What's the structure of the fiber is, which now is making more clarity into that. The fiber structure or the yarn structure has to be first evaluated. What the capacity it takes with it to wick the fiber up, or wick the fiber up on the one.
Right. See, what happens that if we treat the fiber by some chemicals, especially they may be silicon-based chemicals, which will basically try to reduce the surface energy, and therefore will try to wick it faster. But how far it will go, that will depend upon the capillary size. There is a limit beyond which the liquid cannot be taken up, because the capillary pressure has to support the weight of the liquid. So how much length or the column of liquid it can support, it all depends upon the capillary pressure. And the capillary pressures depend upon the surface tension of the liquid itself. If it is water, so that is fixed. We cannot change the surface tension of the water. We can change it by some other means, but for this testing purpose, we don't change it. The other thing is only the value of R. As I showed the first equations, there's delta P 2 gamma cos theta by R. R is the capillary size. Now, how do you reduce capillary size? That may increase pressure. And at the same time, there's another problem also. The capillary size depends upon the fiber diameter. If the fibers are smaller, capillary size will be smaller. If the capillary size is small, capillary pressure will be more. If the capillary pressure is more, the column height is going to increase. That is how we can say that probably with finer fibers, we may expect the liquid column height to increase. Otherwise, this is not going to increase.
Thank you.
Okay.
I think no other question is there, so we can invite the second panelist, Mr. Dinesh Soni from Breakout. It's one of the leading European company. Mr. Dinesh Soni has been sales director since 2019 with this company. And prior to that, he was 21 years with the Reliance, the sales profile itself. So I hand over to Mr. Dinesh Soni to take their presentation forward.
Yeah, namaste everyone. Am I audible?
Yeah.
Okay. Thank you so much. And a brief introduction about myself. I am Dinesh Soni, currently working for Breakout and responsible for our RO West office and our division Bhagavan. So we are actually based in, currently I am based in Thane, and we actually take care of our entire West region sales. And our Breakout company is a multinational company which is headquartered in Germany. And I would like to switch over for my presentation. So somebody can play, or I have to do it. Okay. So we can see this presentation. Dr. Vikas.
Yes, sir.
Okay.
Fine. It's fine. You can move ahead.
Yeah. So I start my actually presentation. As I told to you that Breakout is a Germany-based company, but we have our sales offices across the world. So this is our headquarters, which is actually in Germany, and this is close to the Swiss borders. And we are actually dealing in the precision parts, and we state of art parts are actually supplied, and we give needles to the industry for knitting, sewing, and for the industrial applications. We also supply precision parts and fine tools. We are giving suitable systems to enhance and increase the productivity. We are giving services like technical services and all other services. Regarding the products presence, I would say our products are actually present right from the beginning of the textile operations, which is like carding and yarn productions. So for this, we are actually making carding wires, and then we are actually having a major market share in the knitting industry. So we are making all kind of knitting needles. These are like circular knit, warp knit, flat knit, and we are having our expose and weaving. In weaving, we are making heeled wires, drop wires, heel frames, knotting machines, and cleaning equipments. In felting, we are making felting needles and jetty strips. For tufting, we are making modules. And for sewing, means basically joining applications, we have a large basket of sewing needles and we have a very good presence in the industry. This is the slide which shows what was our turnover last year. We did 742 million euros. We have nearly 8,700 employees across the world, and we have more than 70,000 products in our basket. And we are actually having more than 1,900 products which are patented, and our patented turnover is nearly 13%. So you can say that we have a quite emphasis on our research and development. This is the turnover of our company in last 4 years. In 2019 and 20, it was equally bad for us due to the COVID, but we revived very good. And last year, our number was 742 million. This is how the market size and sales has contributed in our kitty. So this is the graph of, say, last 20 years. And we can see that in 2004, America contributed nearly 17% of the business, but in last year it came to 13%. In Europe and Africa, in 2004 it was 43%, and now it has come to 33%. In Asia, we were nearly 40% in 2004, but in last year we have actually come to 54%. So what we want to say here is that most of the production facilities are migrating towards Asia, and we have a good visibility or growth for Asia. This is our spread of employees across the globe. In America, we have nearly 115. In Europe, we have nearly close to 5,000 employees. And in Asia, we have nearly 3,600 employees. This is an important and very interesting slide which says about our company. Our company was founded by two gentlemen in 1852 and 1871. And these were actually both merger took place in 1937, and the name came from Mr. Gross and Mr. Becker. So now it is called as Gross Becker. We have acquired many business in progressive years. Like in 1980, we acquired sewing and felting. In 2000, we acquired weaving, and latest is we have acquired carding business. This is our distribution of our sales department. You can see that in Europe, we have our presence via 8 sales offices in Germany, Great Britain, Spain, Italy, France, Czech Republic, Turkey, and in America we have 3 offices. But now our main focus area is Asia, and in Asia we have 22 offices. In India alone we have more than 7 offices. Because in India we have resident engineers also and resident sales people, so that's the reason I'm saying 7+. This is the products, as I told to you, that in knitting we have major market share. In weaving, felting, tufting, and carding and sewing, we have good contribution. So tell you about the knitting. We have our needles, which are actually going in the circular knitting, in flat knitting, lag wear, warp knitting. We are making knitting cylinders and system parts, and we are giving our services to all the customers. So these are the components or the products which we are actually making for the circular knitting industry. As you know, this circular knitting is actually more popular in the t-shirts, leisure and sportswear, underwear and nightwear. And the products we offer are latch needles, spring-loaded needles, steel composite needles, transfer needles, system parts, and knitting cylinders. The next is flat knitting. In flat knitting, the products which are actually typically made in the industry are pullovers, jackets, waist, like collars, cuff, hats, and we offer latch needles, we offer spring-loaded latch needles, we offer compound needles, we offer link needles, transfer needles, and system parts. Next come our warp knitting portfolio. This application is actually increasing day by day because these machines are coming at a very, very high productivity. And typically you will find more investors are actually coming with the warp knitting machines. So the products are actually wide range products like shoe uppers, clothings, home textile, technical textiles, and wind turbine blades, bodywork, and women underwear and women clothes. We are making compound needles, we are making lash needles, we have patent needles, and we have spring beard needles, we have system parts, and we have modules. Now coming to the next category, the leg wear portfolio. So in leg wear, you know, means socks and tights are actually made, and we are making needles for the socks needles, dial needles, link needles, seamless needles, and system part. In weaving, we have a wide range of products, and we are making heeled reeds, heel frames, top wires, warp stop motions. We do offer lino weave solutions. We are making tying machines and frames, and this is one of the best and promising product in our kitty. We have come recently with the latest drawing in machines, and these machines are available for inspection in India. So recently we have started our showroom in Icharkaranji, and the customer can go and see this. We do manufacture cleaning machines. These are highly efficient machines, and state-of-art technologies available. We do offer all kind of, say, qualified services to the industry. Now comes to my favorite topic, which is the non-woven industry. As you know, means non-woven industry is actually doing very good in India and Asia. These are very high productive machines which are actually making up to 1 tons per hour. So that kind of actually volumes we are saying. And we make felting needles. We make structured needles. These are actually used for making velour fabrics. We do make jet strips which are used in the spunlace process. We do offer our services and recommendations to the customers, and all these are actually ready-made and available at a single source. Now coming to the more details on the felting needles, what felting needles does is like these are responsible for the fiber transportation, and selection of the needles depend on the fiber, that is the raw material, and the required end properties in the product. So selection will be like defined on the set of machines what we have, and the needle length, and the shape of the working part, and the distribution of the barbs. So we have nearly 2000 types of needles, and this is most extensive, and we can actually give solution to customers in all the segments. We have different actually cross sections available. These are the cross sections available with us. Basically, this is the cross section of the working part in which barbs are actually engraved. So typically you will find when the needles were invented in 1970, typically all were triangular type, but later on these special shapes were developed, and these are actually used for high protective or to improvise the surface quality. Like if I tell you for the geotextiles, you will find tri-star needles are actually more popular, whereas eco-star needles are recommended for improving the surface quality. Teardrop type of needles are actually more popular in the paper machine felts. And we have two more stable needles where they have to do more rigorous job. These are conical and the GB con needles. Now coming to the tufting, as you know, means these are used for making the carpets, carpet tiles, artificial tufts. We offer needles and needle modules, loopers and looper modules, reed finger modules, tufting knives and knife modules, regrinding services, and we do offer a recommendation to the clients, and all these are actually available from the single window. Then finally coming to the carding. So coming to the carding, in carding we do offer metallic card clothing. We do offer stationary flats. We are actually giving flexible card clothing. We are offering flat tops, and we offer recommendation to the customers, and we do offer the mounting services for the customers. Now coming to sewing is basically a very widespread. We have nearly 3000 types of needles available in the sewing category, and these needles are used for the sewing and the embroidery machines, for textiles, leathers, and technical textiles, for the shoe machines and awls. And we have a special application needles. We do offer actually our patented INH quality management, how to handle the needles, and actually this is more rewarding projects for the exporters, because they can easily track down all the needles and any needle breakages there. Now coming to the research and development, as I told to you that we do actually give a great importance to research and development, and we have nearly 254 employees, means nearly 250 employees dedicatedly working for the research and development. Basically, these employees are based in Germany, and we have nearly active patents close to 2000. And I told to you that we have a like turnover of about say 13% of the patent product. A great emphasis has actually given to Technology and Development Center. This is basically a value-added service for our development partners and the business partners. So what they get? They get expert advice and joint solution developments, optimization of process, training and further education along with the textile value chain, taking on development and product management, support of complex development in textile content, what what actually we offer here is like knowledge of experts. We have our project rooms where we are conducting the projects, and these are highly guarded. So if a customer is actually taking trials at our center, then his knowledge or his secrecy is actually very much protected. And we do actually give support for the analysis of the product and any other issues. In our academy, we actually conduct practical trainings. We have state-of-art learning methods, like these can be online or these can be in physical. And we do actually share transfer of knowledge. We give know-how and expertise knowledge. Now, the latest is like we are giving more and more importance on the digital platforms. So right from the beginning, we are actually giving more emphasis. So all the customers are informed about their dispatches and immediately via systems. So they get complete information via emails. Now we are actually moving towards the next step. So we have a web shop, and these web shops are accessible to the customers. They can select the products, and they can actually see the history of their liftings, and all the information about the products are also available. And in time to come, we are going to offer more digital services to the customer. That's our plan. And that's all from Grossbecker. Thank you so much. Hopefully, I have completed within time.
Yeah, just 4 minutes over. Anyhow, it works. It was really very interesting, and for a common man, needle is a needle. But listening from you, you are talking about 3,000 type of needle. It's really a new, interesting knowledge sharing for the other general peoples also. That's really good one. And I know the Grossbecker has very good reputation into the market, and I think is the market leader for so many years for the at least the knitting needle. But I have heard from the Ludhiana or Delhi belt itself.
The
Really,
3,000 needles are the sewing needles. Actually, we have more than 70,000 needles. Yeah.
So for a common man, needle is a needle. But when you go in detail, companies like you, then you really know how the technology has been involved into that, what kind of R&D has been working into that.
Absolutely.
Thank you, Mr. Soni. Thank you very much.
My pleasure.
Our next speaker would be Ms. Vandana Gupta from Chitkara Design School. I hand over to her. She will be talking about the paradigm shift in textile trend and innovation for apparel and allied industries. Hand over to you.
I hope my slides are visible. My PPT is visible.
Yeah, it's fine. You can go ahead.
Fine, sir. So, good evening to respected chairperson, all the respected dignitaries and participants. Myself, Dr. Vandana Gupta. I am a professor in Chitkara Design School, Chitkara University, Punjab. Today, I would be sharing some insights about paradigm shift in textile trends and innovation in apparel and allied industries. In this presentation, I would be talking more about that how the technology evolution has taken place and how the market or industries and brands are using this technology to meet the demands of the consumers. So I would be sharing the same through my presentation. As we all know that textile is the basic requirement of human beings. And when we talk about the application of textile, there are a huge number of applications which can be divided into direct application and indirect application, such as fashion, sports, medical, home furnishing, hospitality, automobile, and many more. And to meet the demands of all these industries so that they can produce the products for the consumers, there has been an evolution of technologies and materials. So when we look at the evolution, we had conventional technology and materials which used natural and synthetic materials or fibers for protection, modesty, projection of image, and wealth identity. Then we moved to another type of technology, which was categorized as performance technology, which included functional and technical textiles using layer by layer assembling, immobilization of enzymes on textile surfaces, nano coating, and nanotechnology. These technology provides multifunctional benefits to the consumer. As time passed and consumer demands increased, consumers became more, I would say, educated. They wanted more. And looking into those requirements, new technologies came into existence where we can say smart and intelligent materials came into existence, which can sense, diagnose, and give proportionate response. In today's century, I can say that there are two important technologies which are taking place. One is the robotic automated intelligence, replacing manpower, but also reducing waste reduction, which I will be talking in the later slides, as well as sustainable technology and materials. As we all know, these kind of sustainable technology and materials are connecting technology, culture, and society. So let us see these technology one by one. When we talk about functional technology and materials for technical textile, I am not going to share any kind of research, but I want to bring to this platform the information that it is not only about researching about these technologies, it is actually into practice. There are different brands and there are different companies who are actually producing the materials using these technologies and providing the suitable, I would say, solutions to the consumers. So one is the HATEX company, which is world-leading manufacturer of laminated and coated technical textiles. And it produces different textiles for military, roofing, environment, agriculture, recreation, and sports. There is another company, which is, it is a nano tech startup named as GoGo Nano. It provides nanotechnology made simple by providing spray, shield, and liquid skin to provide stain and waterproof materials to the consumers. Another technology in this category is Nanotex, which I believe we all know. This company works with different brands like Banana Republic and JCPenney. Nanotex uses revolutionary technology to enhance fabrics on a molecular level. The founder, Dr. David, in 1998, replicated the natural water repellency of plant surfaces and animal coats and developed many apparel, home, and commercial residential interior fabrics for different markets. Now, when we see all these technologies, all these brands are using the technologies which we all know is nanotechnology. This slide is basically talking about that nanotechnology. Many people says that it is the technology of 21st century, but our literature and history suggests us that the nanotechnology was there from in Roman civilization as well. As we know that Roman craftsmen used nanotechnology to create a cup which can change color. When a light falls from the front, it looks green. And when the light falls from the back, it looks red. So the material which was used was in nanoscale, and the craftsmen only knew how to use it as an aesthetic element. So this technology was available in earlier time also, but we are using it for, I would say, comfort and other functional purposes in 21st century. Another technology which is being used for functional and technical textile is biomimicry. I would say lotus effect is one of the best example, where we can provide textile with super hydrophobic surfaces as the same effect of lotus, which repel or which make water droplets move out from the surface. Another example is that when this slide is to share with everybody that we need to connect with the nature, and we need to understand that nature provides us many examples, many ideas to make different kind of products. And this is one product which was developed by understanding the nature, which was developed by Mr. George in 1941, and is one of the important product for fashion industry. Another example is biomimicry, that is kingfisher and Japanese bullet train. The Japanese observed a kingfisher diving into water after prey and adapted the beak design to the train, which made it more aerodynamic, quieter, and reduced its energy consumption by 10 to 15%. So that means the functional and technical textile have used the advantage of all these technologies in one or the other way. Next, we have intelligent and smart technology and materials. And I would like to share one example of smart and intelligent material, which is known as shape memory material. When we talk about shape memory material, shape means the space it occupies, memory means it remembers the past, and material, the stuff it is made up of. When we talk about the stuff it is made up of, these shape memory materials are classified into two categories, that is alloys and polymers. If I talk about alloys, there is one important alloy which is known as nitinol, which is made up of nickel plus titanium. These alloy can remember a specific shape. After deforming, it comes back to its original shape. And it is able to do this with the help of its austenite phase and martensite phase. It can deform and it can come back to its original shape. And there are different researchers and organizations or companies who have used this technology to develop different fashion products, or I would say to solve the problems of the consumers. One example is the lingerie bra product, where the shape of the cup can be after deforming can come to its original shape, because they have used the nitinol wires in weaving or in developing the bra cups. And the second technology which I would like to share is the oricalco fabric, weaved fabric, which is being made by Grado Zero Escape by using nitinol alloy. When you apply a hair dryer, the temperature of hair dryer on the shirt, the size of the shirt decreases. That is, it changes its shape, but it can come back to its shape after some time. So this is the example of shape memory material, which is the smart technology material. Another example is the Cabela's new color changing color phase apparel, where the color changing pigment is being added to the material. And at below 65°F, this jacket can change its temperature according to the atmosphere, and it is being used for the military and army people. Next technology when we talk about is the robotic technology and materials. In the morning, in the inaugural session and other sessions also, we were talking that the textile industry is advancing very fast. There are so many different types of technologies which are coming in. And yes, this is one of the technology which is there in the textile industry, maybe at international platform. That is service robots can be utilized to automate a wide spectrum of industries, ranging from logistics and delivery cleaning and disinfection, to socializing agriculture, underwater exploration, and food service. So such kind of robots are being developed for supply chain, for logistic, and for textile industry or apparel industry, and they are in use nowadays. One company known as SmartTex is providing a solution to circular knitting machine products. This company says that when we develop a product, during the production, the material gets many defects. And in the end, when we check the product, it have defects, and we have to keep that product in a separate area because we cannot send it to the market. So this company is using the AI, artificial intelligence, to check the defects at all the level while producing the circular knitting products. And there are many companies which are associated with this company and have been benefited by this type of, I would say, super inspection provision given by the SmartTex. There is another company that is SVP Worldwide, one of the world's largest consumer sewing machine producer, has launched the world's first sewing and embroidery machine with artificial intelligence and voice control features for home use. In addition, the machine comes with multiple other advanced features, including cloud-based embroidery, editing, design services, and automated embroidery guidance. The sewing machine, as we know, is in the transformation from a mechanical machine to a digital device. I would like to put forward to this platform that when we have produced a machine, the machine used to work with the help of humans or according to the humans, but now machine can be programmed in such a manner, or it can think of itself and develop a product. One such example is software automation. This company is of the US based company, and this company have revolutionized the sewing technique, where they have revolutionary patented fully automated sew bot technology. That means the machine can develop the whole garment by itself. That is, it is a kind of robot who can develop the garment itself as per the programming done or with the help of the data infeeded in the machine. So these kind of technology are there, and industries are using it in one or the other way. So,
Dr. Vanna, please speed up.
Ji sir.
Yeah,
so artificial intelligence and Internet of Things are being used in these robotic technology. Another area which we can see is sustainable technology and materials, where different brands are working on sustainable technology and material. And if we talk about the technology, natural dyes are being used to provide multifunctional effects, properties to the garments. There are researches and work being done to use the agro waste such as pineapple and banana fiber to create textiles which are sustainable. Another important area is the biofabrication, which literally means biology. With the use of bacteria, algae, fungi, yeast, we can develop a textile. And BioCouture is a London-based design consultancy that is pioneering the use of biomaterials for the fashion, sports, and luxury sectors. In the last, I would like to talk about our traditional Indian textiles, which can be considered as most sustainable and zero waste garments in this category, where the handloom sari can be worn by not only one person, but the person of different sizes can wear the same sari. That is, no stitching or no cutting is required when it comes to textiles. When we talk about the drivers of these technologies, there are different drivers such as advances in science and technology, emergence of the knowledge economy, convergence of players in terms of multidisciplinary work which is being done in the form of research and development, new design philosophy and consumer demands have made these technology come into surface. I would also like to say that when we talk about these technologies, we can say that two parallel technologies are there. One is the modern technology and materials, and the second is the traditional technology and material. The only thing which I want to say on this platform is that we need to understand, and we need to think that what society requirements are, and we need to make a balance between modern and technology, traditional technology and material. Other thing is we need to focus more on slow fashion and production, how much to produce and what to produce. And last but not the least, consumer awareness about such products and from where they can buy is an important, I would say, area where everybody needs to work on, so that consumer can be benefited and whatever we are producing or industries are producing can be given to the consumers. I would like to thank end my presentation with this note. And I would like to thank the organizers to give me this opportunity to share my views on this topic.
Thank you, Dr. Vanda. It was really very informative session you have presented over there.
Thank you, sir.
One thing, because I am from the chemical background, I would like to share one thing, that nanotechnology is now in a big question mark now because of the health issue. And it's been not concluded yet, but still a lot of debates are going that it's penetrating through skin into the body. A lot of cancerous product issues may happen into that. You know, the oil and water repellency finishes were previously based on fluorine-based chemistry.
Yes,
that has been totally banned now.
Ji.
It started from the C8 chemistry, then people shifted to C6 chemistry, and now we are talking about only the C0 chemistry now.
Ji,
So
sir.
that's the trend is changing in that direction also.
So,
So
I would like to add one line in this, sir. So when we go for a new innovation, when we go for an innovation, after 10 to 15 years, we get to understand that this innovation is actually the beneficial innovation for the society or not. Like you are saying, now the nanotechnology is being considered as, you know, there are debates about it. So yes, this is the issue when we do any kind of innovation and work on it, sir.
yeah, this is not now, it's from the last 4 or 5 years. The debates are going on, and the many companies are trying to avoid from the nanotechnologies for the finishes.
Ji, sir. Ji, sir.
Thank you very much.
Sir. Thank you, sir.
I'll call the now next Mr. Shivankar Mehti from Uttar Pradesh Textile Technology Institute, Kanpur. They will be talking on conjugated polymer functionalized textile for water purification. So I hand over to Mr. Shivankar.
Yeah, good afternoon, everybody.
Good afternoon.
Yeah, I think my slide is visible now to everybody.
Not yet.
Slide is not still visible.
Now it's fine. Now it's fine. You can move.
Okay. So I am Subhankar Maiti, Assistant Professor at Uttar Pradesh Textile Technology Institute. So my topic of discussion is conjugated polymer functionalized textiles for water purifications. So water pollution is one of the major concern in our country. So basically, the water is polluted by various industry, manufacturing industry, including textile industry. Various textile effluents, they are gradually treated with water, and those effluents are having various heavy metals, and those heavy metals are very harmful for human, animals, plants as well. So the heavy metals such as cadmium, chromium, copper, nickel, lead, zinc, these are the metals which when we excessively consume, then those metals are actually detrimental for our health. So even those metals are present in various dyes, various finishing auxiliaries, even preparatory chemicals such as size paste, scouring solution, bleaching leftover. So water is inevitable in human life, and even for any living beings which are means living on earth, and a huge amount of chemical waste is generated by various industries such as textile, paper, leather, fertilizer, electrical, electronics, metallurgy. So all those chemical waste are having various heavy metals. So suitable purification technologies are required to purify those wastewater before discharging into the environment to minimize the level of pollutants before their acceptable limits. So acceptable limits have been defined by World Health Organizations. The acceptable limits of chromium, lead, arsenic are 0.05 milligram per liter in drinking water. So if we consume the concentration of heavy metals beyond this limit, that will be detrimental for our health. So type of disease or symptoms that may occur after consuming those heavy metals are tabulated here. You can see the chromium consumption in excess. We may have liver or kidney damage, headache, nausea, nickel, chronic asthma, coughing, eczema, okay, copper, Wilson disease, liver damage, etc. So there are various detrimental effects. Even arsenic is one of the major concern in India. There are various news or coming in India. You can see the arsenic poisoning is one of the greatest reason for the growing cases of cancer in people living in India's Ganga plains. And 19% of Indian drink water with lethal level of arsenic. That is published in India News, Times of India, 17th December 2017. And you can see there are various glimpses of images of arsenic poisons and that may occur in the human being. So arsenic is another major concern. So if you drink the water contaminated with these heavy metals, so these are the various disease that may happen: headache, coughing, liver damage, nausea, eczema, Wilson disease, etc. So there are various wastewater treatment processes available: chemical precipitation, membrane filtration, electrodialysis, photocatalysis. Those methods have their merits also, there are demerits also. But those methods are not so much suitable for removing heavy metals from water. So membrane filtration is one of the method, but the operational cost is very high, and the membrane fouling is very quick, and you need to replace the membrane if you go with the membrane filtration for cleaning heavy metals from wastewater. So the alternative method we are thinking about, that is the adsorption and alternative method for removing heavy metals from wastewater. So adsorption is two type: physical adsorption and chemical adsorption. So for adsorption process, we need to select suitable the materials that can absorb or adsorb the heavy metals from the water body. So conjugated polymers are one of the material that can absorb heavy metals. The conjugated polymers, actually known as or popularized as conductive polymers, that was invented in 1970 by three scientists, and based on that invention in the year 2000, those scientists were awarded as Nobel Prize in Chemistry. So polyacetylene was the first conducting polymer. After that, polypyrrole, polyaniline, polyphenylene, polyethyl thiophene, these are the various conjugated polymers has been invented till date. So majority applications of those conjugated polymers are for their electroconductive applications, their electrical conductivity. But the new dimension or new application area of these conjugated polymers is the adsorption of heavy metals, because those polymers are having capacity of ion exchange. So the synergy of textiles and conjugated polymers. Now those conducting polymers are good enough absorbing heavy metals, but a suitable substrate is required so that their handling or their uh, handling will be proper. So it is the textile materials are a suitable substrate over which those conducting or conjugated polymers can be coated with, so that we can get one composite material which will be able to absorb heavy metals from wastewater. So in this sense, we have coated conducting polymers. One of the common conducting polymer is polypyrrole and polyaniline. So polypyrrole coated adsorbents we have prepared. So various textile fibers such as cotton, jute, and these fibers are coated with polypyrrole, as well as some cellulosic materials such as wood sawdust that has been coated with conducting polymers, and they have been tried for heavy metal removal. It has been observed that they can be very potential material for absorbing chromium and arsenic from wastewater. So mechanism of absorption of chromium ions and arsenic ions are shown here in this diagram. So the preparation method of these adsorbent polypyrrole coated textiles that has been shown here in this diagram. You can see, if you have a textile fabric, just dip in a monomer solution. Monomer will be the pyrrole when you are going to use polypyrrole. Then monomer enriched nonwoven fabric, then that will be dipped inside an oxidant solution, FeCl3 solution. Then as a result, in situ chemical polymerization will initiate, and after 1 hour of polymerization time, you can have this kind of black color polypyrrole coated textile material. And this textile material will be a good absorber of the heavy metals from iron. So here in this slide, you can see the polypyrrole coated jute fabric that has been dipped inside in wastewater. This wastewater, or you can prepare in your laboratory by using some standard calibration solution. 10 ppm chromium solution has been prepared. That calibration solution has been provided by Agilent company. So here in this solution, chromium is there in the concentration of 10 ppm. So after agitation at room temperature for some time, the clean treated water can be observed. The concentration of chromium in the solution can be measured by some instrument which is called as microplasma atomic emission spectrometer. So by this instrument, one can check the concentration of chromium in water, but that treatment will be there in the very low concentration, in ppm level concentration. Okay, so now the same concentration can be verified by using UV spectroscopy. So UV visible spectrometer can be used to analyze the color of the solution, because when you will dissolve some chromium salt in water, the color of the solution will be pink. So there, this blue line and red line. The blue line is the water before treatment, and red line is the water after treatment. So in the blue line, you can see there are two peaks. One is around 300 nanometer, another is around 370 nanometer. These two peaks are attributing to the presence of chromium 3 and chromium 6 ions respectively. So in the after the treatment, in the red curve, you can see the peak height at 300 nanometer is reduced, and the peak at 370 nanometer is totally vanished. That means the chromium 6 ions has been totally removed from the water by the adsorber. So in this graph, you can see the effect of polypyrrole add-on and the concentration of chromium. So if the polypyrrole add-on is increasing, this graph, the triangle one, if the polypyrrole concentration is increasing, you can see gradually the chromium concentration in the treated solution is decreasing. So higher will be the polypyrrole add-on in the textile material, higher will be the removal efficiency of chromium from the solution. Now, conjugated polymer coated material for arsenic removal. Now we shall talk about the efficiency of arsenic removal. For this experiment, we have prepared various coated material. The first one is the sawdust, that is the uncoated sawdust, that is the wood sawdust, wood particles basically. Then polypyrrole coated cotton textile, polypyrrole coated jute textile, and polypyrrole coated wood sawdust. So we have treated the solutions. We have first prepared the arsenic solution. Arsenic solution is prepared by dissolving arsenic oxide in water to make a 7.5 ppm solution. Then the treatment has been given with all this type of adsorbent, and after that the concentration of arsenic has been measured for different adsorbent weight. Okay, it has been observed that as the adsorbent weight is increasing, the adsorption efficiency is also increasing. So the best efficiency is observed in case of polypyrrole coated wood sawdust. Okay, so followed by polypyrrole coated jute, and followed by polypyrrole coated cotton. So this polypyrrole coated composite can remove color also. The color of the solution that is also can be observed that
Mr.
the color
Shivankar, can you
yes.
just take it's already late. One more speaker is lined up.
Okay, I shall finish quickly. Sir.
Okay.
So the efficiency is also very high. You can see the color removal efficiency is more than 97%. Now effect of time. So if you see the effect of time graph, you can see that the absorption is very quick. So within a 5 minutes of time, treatment time, the most of the heavy metal ion can be removed. Now absorption kinetic, you can see here also the kinetics. You can see the rate of absorption is very quick. So the treatment process is very quick. Now effect of pH. So generally neutral pH, everybody want to use neutral pH, but it has been observed that the removal of zinc, copper, and iron, those metals can be removed removed from the neutral pH. But when you are going for removal of chromium, acidic pH is favorable. Then removal of color. So we have also experimented on the removal of color. So the methyl orange can be successfully or efficiently removed from the solution by using those absorbent. That result is also presented here. Then regeneration. So it is the process of regeneration of the polypyrrole coated material for repetitive use, because once we have used that solution, that material for treatment, then the material will be loaded with the heavy metals, so that cannot be used repeatedly. But there are some back process or regeneration process with that is the treatment with some alkali. So by treatment with some alkali, we can revive the potential of absorbency of heavy metals, and we can use those materials repetitively. So now come to the conclusion side. PPI coated non-absorbent are very simple to prepare in water media, as I have demonstrated. In normal temperature, and very low chemicals and reagents are required for the preparation of the absorbent. These bioabsorbents can be used to treat the drinking as well as wastewater for removal of harmful metals and colors. The absorption capacity of absorbent can be regenerated by simple alkali treatment, and the water treatment method is simple and require very low energy, less time, and low operational cost in comparison to other existing process. So these are the references. Thank you for your attention, and if you have any question, so you can ask me.
Yeah, Mr. Subankar, is really very interesting topic, because now many things industry water management or water effluent management has been controlled very well, but still the issue of heavy metal is still the proper solution. People are looking into that. So that's really very interesting information you have shared, and I hope this will in future move into the real practical world also very soon into that. Thank you very much.
Thank you, sir.
The next speaker is unfortunately, I don't know whether it's Miss or Mr. because it's written as S. Kubera. Is there? Hello? Anyone for Vignan's Foundations?
Is any participant left? Then they can give their presentation.
I think not present now.
Yeah, I guess he's not here.
Yeah.
Oh. So shall we end this session, sir?
Yeah, let's end this session now. Thank you very much, all the learning speakers. And thank you, Vanda. You also managed very well the show. Thanks a lot.
Thank you, sir.
Thank you very much.
We would like to thank our respected session chair, Vikas sir, for beautifully conducting this session. I would also like to thank all speakers for sharing their incredible work with us. Thank you. Thank you all. Have a great day.
Thank you. Bye-bye. Good day to everyone.
Firstly, the preparation of fabrics was done, then extraction of essential oil was done, then preparation of finish and impregnation of fabrics, then and olfactometry analysis was done, then assessment of washability was done, then mosquito repellent property was checked, and it was applied on end products. So, firstly, after preparation of fabrics like scouring, desizing, the extraction of essential oil was done. This was done by of a clevenger apparatus, which fresh leaves of citronella and lemongrass plant was collected. Then the was shade dried and put into the flask in the material to liquor ratio of 1:3. Firstly, the temperature was set to 100 degrees centigrade, and after boiling started, the temperature was set to 60 degrees centigrade. After 4 hours, the essential oil were collected in a beaker and transferred into the glass bottle. Then after this, the impregnation was done. Coffee beans were snipped between to avoid mix of aroma. Breath in through nose at distance of 1 centimeter and no touch to nose. Respondents were instructed to take 3 to 4 breaths only. Then the average categorized like very strong, medium strong, weak, and very weak. And which was given for very strong, it was for me, 3, and for weak, 2, and for weak, it 1. The score was calculated multiple frequency of each range was found. The range is showing there for very strong was between 5 and 4.8, and for strong was between 4.8 to 4 to 3, and for weak it was 3 to 2, and for very it was. Then the check ability, sample 5, 10, and 20 was each were again nice to the intensity of the aroma. That the was checked, it was done by a wooden cage was prepared, which side effects were food and was $20 mosquitoes were exposed in the cage. The number of mosquitoes treated fabric and the mosquito test on the every 10 hours for 4 minutes and calculated by using following formula: mosquito repellency percentage equal to number of mosquitoes on control sample divided by number of into 100. The mosquito repellency percentage was calculated by using this formula. Then this is the table is showing the result of olfactory analysis. And that wool showed best result among all other fabrics. As on the 5th day, the spectrometry analysis was for the period of 1 month. On the fifth day, from fifth the samples were smelled every fifth day. On the fifth day, it shows very strong, and at the end of the evaluation, which is on 30th day, it shows 4.2, which shows a strong aroma. So all the fabrics, wool shows results. Retention of retention of aroma. This table shows the fabric treated.
Rohini, I think we should request Dr. Srivastav to make a recording at her end.
Yes, sir, my connection is not stable. Very sorry, sir.
No, Dr. Shivani, you've done some excellent work, but unfortunately it is getting lost in the variation of the signal.
Yes, sir.
So
Unstable connection, yes.
Yeah, may I suggest that you record your entire program, your entire paper, and send it to us on mail so that we can include it
Yes,
in our recordings.
Okay, sir. Sure, sir. Thank you so much.
Otherwise, you put in so much effort. I really feel sorry, but unfortunately,
Yes, sir. I am just. It was okay earlier, but this time it is not working properly. No, why?
This is really quite interesting topic, and globally people are looking for such solution for that product. Till now, the permethrin-based products are available, Moscow repellent, which are being now banned. US is not allowed to import these kind of products. So if such kind of product, based on the natural products, is really going to be very big hit into the market.
Right, Dr. Shivani?
Yes, sir. Patent process is in progress.
Please mail it to Ms. Rohini
Yeah, in
or
progress.
Dr. Chetna,
Yes, sir.
right?
Okay, sir. Okay.
Thank you.
Thank you so much.
Thank you very much. Thank you.
Sir, at the end of this session, I would like to thank you for chairing this session so beautifully. And thank you all for attending this conference. We'll meet tomorrow at 9. Till then, bye.
Thank you, Rohini. Thank you.
Yes.
Bye.
Thank you. Bye.
Okay, bye, Rohini. Thank you so much.
Thank you. Bye-bye.
Bye-bye, sir.
Thank you. Bye.
Can we leave now, sir?
Yes, you can leave.
Thank you, ma'am.